Check test. Test 1 2.
Hey. Dean, check. Hey. Can you see me, no? Yeah. Really, you can see me. My face is proper. Clear. It is clear. Freshnel. Clear it is.
Vault also you have?
No, just C type.
And HDMI or you have the HDMI also.
Yes.
Yeah.
HDMI as well.
I got HDMI.
Yeah.
No, no problem. Yeah, no problem.
Yes.
Because you have an extension board also backup if you just need anything. There's the power.
Okay.
So you can just
Cool.
plug
Yeah.
any power supply.
Yeah.
Because you will not this.
Yes.
How are you? Fine, thank you.
Oh my god!
I wish I were a bird.
Hello, hello. Hey, test, hello. Yeah, good. Thank you.
You can just keep this click over here.
Yes.
Hello, everyone. How are you? Fine, thank you.
Oh my god!
Hey. Yeah, check. Less than that. Put it less. Thank you. Ada, battery. Hey, hey. Yeah. Bro, you need to just put this around you. Just like a hairband, how you just wear it. Only thing it has to come on your ears. Yeah. Perfect.
Right?
Yeah. This goes to your mouth. That's it.
Okay. Hello.
Yeah.
Hello. Yeah. Great. Yeah.
So it's
Yes.
not too tight.
Yes. All good. Yes. Great. Cool.
Good, right?
Yeah. Yeah. Great. Thank you. Yes.
You'll be going out for some time or you'll be here now?
No, no. I'll be here.
So, because if you're going out, it might cut, so I'll mute you.
No, no. It's all
Want
good.
to keep it on or mute you?
Yeah. Mute right now. Yes. Hello. Hello. Test. Test. Hello. 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 Test. Hello. Hey, brother. Hello. Are we good to go? Are we good to go? Should we start? All right. Hey, everyone. Good morning. So, welcome to the talk, and it would be a bit interesting, right? So,
Hello, everyone. How are you? Fine, thank you.
Oh my god!
yes. So, hello, everyone. So, in this talk, we'll be seeing some cool attack vectors that are not so popular in this world of smart contract security. Like we all know, there's reentrancy, there are DeFi bugs, but Solidity needs some love as well. Come on, that's our favorite language. Cool. So a brief introduction. Who am I? My name is Tejas Rastogi. Pretty hard to pronounce name, so just call me Tej. What I do, I'm a security auditor and researcher at Consensus Diligence. Besides that, I work on some open source stuff like RazorSec, CipherShots, and Unchained. What are these? These are just some platforms for the community so that we can grow and learn from each other. CipherShots is a CTF platform. Unchained, again, a blockchain security conference that we host. So a couple of things, yeah, it doesn't matter. Like, if you want to follow me, you can find me at Twitter, Razor Tweet, where I tweet some stuff. Okay. Cool, so this is the agenda. There are a couple of things that we'll be discussing, and I will try my best to keep it a bit spicy. And here you go. So the first one we should discuss is something related to call data, right? So what is call data? A brief introduction. Well, if there is a function and you want to interact with it, you have to you're supposed to pass some input data, and that input data is called as call data. Simple as that. So below you will find ABI encoded call data with the first 4 bytes as a function signature. Rest are the parameters, which are ABI encoded. Yeah, that's how it works. Cool. So these are the parameters, and this is how it looks when these get ABI encoded. And right, so let's talk about some dirty higher order bits and how these actually matter. Right, so suppose you have a function which accepts a uint8 parameter, right? So what compiler needs, or what's the utmost concern, is the last 1 byte, right? Nothing else. Like if you're passing any other data with the call data, it should not be, it should not matter, right? But it actually doesn't work like that. So here you can see this one, the first one, is the actual ABI encoder parameter, or typically or logically that's how it should be. But if you're adding some more bits, that's going to work as well, right? like where it can work. For instance, you're writing some very optimized code, you want to work in assembly, right? You're directly storing value using stores in the slots, right? So this one actually works like this in compilers greater than 0.8. So how it works, firstly, Solidity takes a parameter from the call data here below. It extracts the 1 byte, the last 1 byte, that's what we need because we are dealing with just uint8. And after the extraction, it does a EQ to validate it again that whatever we have extracted is actually the call data we want, right? So we have passed hex 17 as a uint8 parameter. We did an AND with FF, the last 1 byte, to extract the parameter, that is 17. And after that, the compiler actually did or performed an EQ, or equal operation, to verify that the actual call data is the same with whatever we have extracted. But it doesn't work like that in compilers below 0.8. So in below 0.8, it just extracts the value, whatever you have passed, and it forwards to the next operations. So imagine you're passing, let's say, a price, and you expect that the uint8 will be limited to 0 to 255. But the attacker can pass extra higher order bits, and if you're using assembly and storing directly, you will be getting a higher price, because that's how the higher order bits work. So there's no restriction in compilers less than 0.8, which has been recently added in the 0.8, and that's how it works. So this is the first one. Let's jump on to call data malleability, right? So again, many of the times we keep the message.data or call data as a kind of a unique identifier to say, okay, this identifier had recently got validated, and now it should not be passed again. So this is a simple scenario, right, from a CTF. So let's say there is a pawn function asking for a valid byte32 token. It could be any token. So firstly, what we are doing, we are verifying that it should not be empty. It should contain some value. And it should be the one that I have, like in my protocol, the verification token for the message sender, so that it should not be passed any other random value. Then what we are doing, we are hashing it down and keeping it as a unique identifier, right? So that's cool. That's how the developer thinks that it will work always, because if you try to pass a different token, that will be a different call data, and the identifier will be different, so it won't work according to the mindset of a developer. But what if I pass the same token and add some data or append some data at the end, right? So this one, you can see, is exactly the same call data with the same function signature, same parameter, but these are two different hashes, because I have appended some random data which will not be utilized in this function, because it will just be taking the first ABI encoded 32 bytes parameter, which is a valid token. So the second check, token is equal to verification token, will work because the token is right, but it will make a different hash, right? So this check, the next one, that this should not already be utilized, will be bypassed, and yeah, just because there are two different hashes. So call data is a unique thing, right? So if we are writing something in assembly, we should take care about these kind of stuff, or we should add some checks so that we are dealing with the parameters we want, right? Great. So this is a CTF challenge, right? If you want to try out, I've created one. You can play it. And it's available as Cybershots. Like if you want to check, go into the slides and you will find it. Cool. So next thing is we can talk about some gas griefing. So before that, like what's gas? Simple introduction, gas is like a fuel. Every transaction needs it to run some opcode, some instruction set. So every transaction needs some gas. Simple as that. All right. Now, in order to understand gas griefing, we have to consider EIP 150 as well. So what EIP 150 defines is every subcall, like what's a subcall? Subcall is when a contract is trying to interact with another contract, making a subcall or making a message call like this one in green, target.call. So it's making a subcall to another contract. So what EIP 150 defines that every subcontext, every subcall context can only consume this much amount of gas and nothing more than that. So, but what if we do something good with it, right? We'll see. So here below is just a simple demonstration of how it looks. Great, now let's talk about gas griefing. So what if we do something so just that we do not allow the transaction to execute entirely, but partially, right? So let's say there is a function which is kind of giving you some shares by taking some tokens from you, like you're buying some shares, right? Like you're giving it 100 tokens and you're buying some shares, right? So the above operation, the sum operations that are listed down, what these are doing, these are giving you some shares, and the last call is trying to take tokens from you, like as a trade-off, like a trade is going on. So it allocated you some 100 shares, and now it has to take 100 tokens from you, right? But this target.call not gonna happen, like not gonna execute entirely, and it's gonna fail. Why? Because we know that the subcall can only consume like 63 out of 64 amount of gas, typical like that. So we are calculating the gas, and we are giving it a gas accordingly so that the top level transaction will work, but the subcall will not be getting enough gas to execute, right? So this will fail silently because we are not checking the status of the call, right? So that the call where we are actually taking tokens from the sender or from our user is failing silently, and the attacker is getting free shares because the top level transaction is getting executed, right? So this is one way we can do some gas griefing, all right? There are other stuff as well. So this is again a CTF challenge you might want to try out. The name is Maya, and it's again available on CipherShastra. Great. Moving on to the second gas griefing, the second pattern that we have. So with this one, we can actually perform some DOS, right, denial of service. How we can do that? All right. So previously we discussed about subcalls. We can use subcalls, and we can give a considerable amount of gas so that only the top level transaction works and not the subcall. But let's use this subcalls to exhaust the gas deliberately and not allow the top level transaction to execute ever, right? So yeah, what could be a possible scenario for this? Let's imagine, yeah, our very famous, our beloved challenge king of the ether, right? So you know how we solve these challenges. Like there is a king, a defined king, and if you want to dethrone that king, you're supposed to send more ether to whatever the last king has sent so that he will be dethroned and you will be the new king. Now, in order for the last king to be dethroned, it is necessary and important that that transaction, the transaction where the ethers of the last king will be sent to him, should be executed, or is necessary to be executed, so that in order to move to the next operations. But just imagine if we are not allowing the previous transaction to execute such that the whole transaction will not work. Now you must say we can do that by reverting the last transaction, right? But that's the point, right? We are not checking the status code. We're not checking whether the last call executed or not, right? So if you're trying to revert, the last king is trying to revert, that's not going to happen, right? Because even though you're reverting, I'm not checking the status code of the transaction, and it will always execute, right? It will always work. So, but still we can do something, right? How we can do that? Utilizing the return data copy. So what it does, as the name says, it returns the data from the last call that just got executed, right? So here you can see, but the problem is whether you need it, whether you want it or not, return data copy will always be there after a call is executed, right? So let's say there are two instances. First one, we don't want, we are not requiring the call data. Second one, we want it. We want this parameter return data. But it doesn't matter. In both of the instances, there will be an instruction return data copy, right? So it's like whether you need it or not, it will always be copied, right? So now how we can do that? Let's take the same example, right? Let's take the same function. There are some operations going on. Then there is a subcall. And then there are a few more operations. And as we discussed, the middle operation, the middle subcontext is needed to be executed such that the whole top-level transaction should work. But what we are doing in this subcall, this one here, the attacker is trying to randomly copy a huge chunk of memory, right? Now, you must be wondering, okay, yeah, I got the point, but the subcall can only consume 63 of 64 of gas. So let it consume everything, but there will still be 1 by 64 left for the top-level transaction to execute the rest of the stuff, right? But it doesn't work like that, because the copying of memory doesn't happen here in this gas. It actually happens in the top-level transaction, right? So whatever the attacker is trying to copy, it is actually not utilizing the gas it's getting from the 63 by 64 gas. It is actually utilizing the gas of the top-level transaction, right? So what we can do, we will randomly copy a huge chunk of memory in order to not allow the top-level transaction to have anything left to process the rest of the opcodes. And what will happen? It will reward, right? So even though created, the name is Kingslayer, yeah, a modified version of King of the Ether challenge. So if you want to try, you can try it out. Cool. Now let's talk about a new thing that recently got popped up. And I'm pretty sure that will be a new attack vector, just like read-only reentrancy. You can think this one as a different pattern of read-only reentrancy. It works kind of like the same way, right? So now what it is all about, right? So I wondered that a same transaction gives you a different value if you call it twice, right? Now you will say, yeah, it's fine. Like if you're calling a function, what I will do, I will just check whether my function has been called once. If yes, I will give you one value. If you are calling it twice, I will give you another value. Simple as that. Yeah, I'll just keep a state counter, right? And I will just check it, like if you're calling it once or twice. But what if it's a view function, right? What if it's a view function and you cannot do or update the state or do nothing, right? Can you still manage it to give the victim two different values if called twice? Yes, we can still do it, right? So this is how we can do it, right? So what we are doing is, let's imagine, like this is a very random example that I've created. There might be some real-world examples, but yeah, just for the understanding, here you can see there is a function exec, and what it's trying to do is firstly fetching the oracle price, and just to make sure you're not giving, or the oracle is not giving a random value, we are just having a check that the value should be at least equal to or more than the minimum price, right? And then again, we are just updating a variable current price with, again, fetching the oracle or price. Simple as that. But what the oracle is trying to do, firstly, is checking what's the gas left right now. If it's less than, like we know for the first time, this call, oracle.price, for the first time, when the function will be called, there will be enough gas, like more than at least 11,800. So what it will return? It will return 500. to verify and validate the check, the conditional check that we have, that it should be at least 500. So we are verifying that. But the next time, you're calling the function again. But what I will do, now, as some of the opcode, some of the instruction has already been executed, so there is less gas left than the 11,800. Now the view function will give you 0. So even though you have verified the check, the conditional check, you are still having a manipulated value that I have sent you, right? So here, the Oracle can give you 0. So what's the problem? The problem is the uncached values. So this is a new attack vector that people should take care of while auditing code, while doing code reviews, right? So what could be a solution, right? Doesn't matter. If there is a function call, right, just cache it down and use it for the rest of the operations, right? Do not like fetch again and again because now we know it. This can be done. Right, and moving on to what are metamorphic contracts, right? So this is again a cool new thing, right? So we all know about the upgradable contract, the proxy pattern, the typical ones. There is a proxy, there is an implementation, the delegate calls, like when you call a function of the implementation, the delegate call will work and perform the logic in the implementation and take the state of proxy, a simple pattern, right? So if you want to update the logic, the implementation, what you usually do, you go ahead, upgrade the contract, implementation contract, and what happens, there will be a new address, right? So if someone wants to check, it will be a bit skeptical because there will be a new address containing, so like, doesn't matter, there will be a new address. So people will get to know that something has happened in the past, right? But what if we do it on the same address itself, right? We change the code altogether, right? So now you must be saying, okay, like how we can do that, right? That's not a fundamental property of blockchain. You're not allowed to overwrite the code. Yeah, kind of, but we are using self-destruct, so we are making use of it, right? So, okay. Yeah, a good explanation is given here, implementation, sample implementation, so we'll have a look. All right, here it is, and cool. So how it works, firstly, there's a bytecode, a metamorphic bytecode, like what it is trying to do. We'll have a look in a moment. And the first operation, the first thing it's trying to do is get your contract, which you are trying to modify or morph after some time, which you want to upgrade. So firstly, it will deploy that contract, the implementation contract, store the address into a mapping here. Why we are doing it, we'll have a look. Then it will deploy the metamorphic code, right? So let's talk about what's the bytecode that we have just seen, what it's trying to do. It's pretty simple, right? Firstly, let's run it. Yes. So here you can see it's putting some parameters on the stack. And that's a problem. So we have to scroll up and down. But yeah, let me do it. Yes, right. So it stored 4-byte signature in memory, and rest of the parameters are the parameters of the static call, right? The gas address, the parameters of static call that we have. And what are these 4 bytes? What the signature is all about? Well, this is the signature of this function, get implementation. Yes, this one. So there is a function get implementation, and now how it works, when you deploy your metamorphic code here, it actually calls the constructor, right? Because whatever we have will be called as a part of constructor. So this one will be executed, right? So we are storing the function signature that we will be calling out later, right, in the static call. So what we are trying, we are fetching the implementation that we have recently deployed, which was the first step, here, right? Remember, we deployed our implementation contract, this one. So what it's gonna do, it's gonna fetch the value from the mapping, making a static call, right? And then it simply fetch the size and simply do IXT code copy to copy the code of that implementation and overwrite itself, right? A simple process that happens, right? So what it's gonna do, it's gonna deploy a boilerplate metamorphic code, and the opcodes will run as a part of constructor, and these opcodes will take the value, the address from the factory contract, fetch the address, and take the code and overwrite itself. A simple process. Now, if you want to morph this code, if you want to override, if you want to upgrade the contract, you just need to go back to the factory, redeploy a metamorphic contract, and redeploy implementation, and you know what will happen? It will take the same exact address. Why? Because we are utilizing create2, and we can pre-calculate the address, right? So it's gonna use the same address. The important part is the first one needs to be self-destructed, because we cannot redeploy on the same address. So you have to self-destruct the first address, and then you can perform the same operation again. It will calculate the same address, deploy a metamorphic code, and that metamorphic code will take the address and override the new data. The problem is the state will be lost because we cannot deal with it. We are self-destructing, so state cannot be maintained, preserved, right? So imagine there are some non-technical people just randomly following a protocol, having trust in it. And let's take the same example of Oracle. The Oracle is giving you a price from A plus B, and the non-technical guys woke up next morning and finding now it's giving a price of A plus 2B. And what happened? They really don't know because it's the same address. Everything happened on the same address. It's the same state. Now, let's imagine there are some libraries. We don't even need the state. We are just referring to a contract to fetch some functions, like as I mentioned, A plus B or A plus 2B. So yeah, it can do some damage, right? It can, the developers, the team, can manipulate and modify the prices that you're getting. So always, for the auditors, if there is a self-destruct and if it can be controlled by the authorities, by the team, you should always flag it, right? Because nobody knows what could happen with this stuff. All right, so this was a metamorphic contract. This was, again, something that's very considerable and concern. And we have actually seen this. I cannot disclose the project, but we have actually seen this stuff live in a protocol that we audited. And yes, we have flagged it because we don't know if the team is trustful or not. Yeah, we trusted, yeah, because they came up to us for the audit, but nobody knows. Right, so this was something we discussed. These are the steps that we just discussed. Cool. All right. Yeah, another cool thing, code injections, right? So we always talk about Web3 when we talk about Web3 attack vectors, right? Web3 kind of feels alone in this world, right? Because we are kind of missing our old school attack vectors, our SQL injections, RCs. Why not in Web3? Like, let's use them together and let's have beauty from both the worlds, right? So what we can do, let's imagine some accesses, right? So let's imagine there is a platform like OpenSea, right? And there is an NFT with the token URI that you can control, and you can add any data that you want. And on the front end, on the application, there is no input standardization or input validation, so you're free to pass in any data that you want. And what you're trying to do, you're randomly passing a script in the storage, and that is being fetched on the front end without any validation. So imagine creating a login form, right, in the platform and saying, hey, go into this site this is the NFT that I created. You just need to log in with your credentials, and you will get your NFT. And that credential or that login form has been created just utilizing the vulnerability of the application and not from the Web3 world, right? So this is one example. Cool. This is a practical, you can say, understanding that you can think about. This is how OpenSea fetches the data from URI. So, and it creates a page here, right? So you can see there is name, author, there are properties, there are traits, everything is there from the metadata, right? And that's what we discussed. If I create, or if I pass in some values which are not being validated, I can create anything possible and the page will render it. So what could be a solution? Use some inner text and don't use inner HTML. Do not render what you're getting. Do not execute like inner HTML. Like even inner HTML is fine if you're keeping some validation. Now imagine you're directly proposing or directly doing some exec, JavaScript execute. So whatever script is there in the storage, you're directly running it. Now, what could have been done? There could have been an RC, right? So you could have created a shell on the application and can access the system. So that can also happen as well. And we have seen this kind of stuff in some protocols because they don't care about the front end, because they think that my protocol is like, doesn't make sense for them because it's just a plain front end and they're just fetching data from the storage, like some usernames, right? The protocol is allowing you to create any username you want, right? So instead of doing a username, you're just creating a script supposed to be executed on the front end, right? So that is one. And there could be anything that you can do if there's no sanitization. Cool, and let's talk in the end some bad patterns that we should take care about. There are multiple, but I have kept one. Static calls. So static calls are a nice little thing. They do no harm. They are cute. Yeah. So, but let's imagine we are writing some assembly code. We love writing optimized code. We are not like writing in high level, right? So what the feature of static call, it doesn't allow you to modify the state. You just have to work with the static state that you have. You are not allowed to update it. Cool. So, but what if we are using a stale memory in order to execute the rest of the operations? Or my other functions are depending upon the stale memory that we just have discussed, right? So what could happen? So I've created one example here. I'm storing a value at location 0, and this x is just to demonstrate like what was the value previously, making a static call, and then again fetching the value at 0 to verify what's the new value, right? So this is what happened in general in a normal scenario. There's a function random which is returning a value UN 5000. These are the outputs. Like firstly, the value was FFFF and the memory location 0. We called the static. We did a static call, return 5000. This was a new value, and Z is the status. Whether the call succeeded or not, right? So this is all normal, right? But what if the function is reverting and doing nothing, right? So you're doing a static call, you're doing all the same thing, but these are the results. So earlier it had FFFF, the call failed, you can see the status is 0, the Z value. So the memory is still having FFFF, right? So now imagine you're believing your function that it will always give you some value, right? And you're proceeding with the value return with it, right? So imagine, again, the same example of price. You're saying, hey, the oracle will at least give me some value at some point of time, right? And I will not work with the random value that I already had previously. Now, in which scenarios it can happen? I used zero location. Zero is usually kept for hashing, the first 64 bytes. So imagine there was some hash, there was some stale memory, there was some random data already there in the memory, and you believe the static call will give me some value, the return value, and I will proceed with it, right? I will take that input, and the rest of my operations will work with that value. But imagine the function is reverting, so you are actually working the value that you had previously and not the value that you recently got, right? So this is how, this is a bad pattern that you should always take care about if you're making a static call. And what you can do, simply check that what's the status code. If it's 0, should not move ahead, and keep it right there. So I guess with this, these are my tag vectors that I think would be worth sharing about. And if you have any question, feel free to raise your hand or just shoot it out. All right, thank you so much. And with that, thank you for listening to my talk and being here. We'll see you around, and yeah, later.
Check. Okay. Can I go? Welcome, everyone. I am Uri, and we're going to take a stroll together down the security tools zoo. If you look at the world of security tools that help you find bugs in smart contracts before you deploy your code, we can see that there are many different technologies, and each of them has a very intimidating title that sounds very scientific and foreign to most people, like static analysis or formal verification, invariant testing. Seems like you need to have a PhD just to understand these terms. So today we're going to demystify them and explain what they actually do. And we'll briefly go over how they're implemented, but we'll only scratch the surface. What we will dwell on is how they're actually used in practice. What you should be mindful of, what you should try or not try to do, what are the limitations, and so on. And after we do that, we'll also learn how can we measure the effectiveness of our tool usage. And obviously, we'll also see some cute animals along the way. At first, we'll start by explaining what tests are. It's just to set up the discussion. Tests are the first line of defense that you have against bugs in your smart contract code. In this presentation, we'll take as an example a transfer function that gets 3 different parameters, 2 addresses and an amount. And that amount should be transferred from the first address to the second. So a test could look, for example, like this in Forge, written in Solidity. So here we have a test that we transfer 1 token from the address called Alice to an address called Bob. And then we check that Bob's new balance is equal to exactly 1 token. So one common theme among all tests is that they all check for a specific input. 2 specific addresses, Alice and Bob, and a specific amount of 1 token that we try to transfer. We're also checking for a specific scenario, a specific combination of specific functions. In this case, only the single function transfer. What people sometimes tend to miss is that tests usually only look at one specific starting state. What we usually do, say, in Forge is that we have a setup function where we tell it what are the 2 addresses that we are going to care about, and we're minting tokens, so we are actually setting a specific balance for the tokens for those addresses. So a test is a combination of very specific things. Examples for unit tests that you're probably pretty familiar with this is that we'll probably try to transfer 0 tokens, transfer the max UN 256 amount of tokens, transfer the entire balance of Alice to Bob, try to transfer to the 0 address, and so on. And if tests were an animal, they were a mole, because a mole is blind. A test checks only the specific thing it was set up to do. Tests are cheap to write, they're fast, and their largest advantage is that it's easy to understand relatively what went wrong when they fail. Because you wrote the test, hopefully you wrote some documentation of it, and you're looking at a very specific thing, so it's relatively easy to trace back and see what went wrong. And again, as we said, they have low coverage, specific starting state, input, and scenario. If we want to scale it up and check more inputs, then we should look into fuzzing. And there are several fuzzing tools in existence. One of them is Echidna by Trail of Bits, and there is Foundry, and there is a tool by Consensus Diligence, and there are many others. Fuzzing is the process of generating many, many different inputs automatically and testing all of them. When do we stop? So we allocate some limit to the computation. Usually it's either a limit on the amount of iterations, the amount of different inputs that we put, or just the amount of time. Try as many inputs as you can in 10 minutes. Obviously, the more resources we allocate to the fuzzing and we don't get an error, the greater will be our confidence that we don't have a bug in the function that we test. So obviously, there are some examples here on the screen. It's just inputs that may look completely random to a human. However, in practice, they rarely are truly random. Fuzzers are always smart to some degree. The inputs are not truly random. Fuzzers try to optimize for example, coverage. Many fuzzers will try to cover as many branches as possible in your code. Some fuzzers are even smarter than that and will check for some storage values in your contract and try to use them as different inputs, and so on and so forth. This is the difference between the different fuzzing products that there are. Some fuzzers are actually even smarter than that and can check a different type of test we call an invariant. An invariant is something that is always true about your system, even as it goes through transformations. And there are many invariants in DeFi. One of them you can see on the screen. This is a simple token invariant. We say that the total supply of the token is equal to the sum of the balances of all the different addresses, which should always be true. It doesn't matter which function we're calling. That's why it's an invariant. Another type of invariant you can think about is what we call solvency, and that could be, say, a property of a vault, and that's basically the opposite of what happened to the SVB bank. We always have enough assets to cover all our liabilities, and so on and so forth. And how fuzzers can actually check these invariants is that they call random functions, and usually a series of calls to random functions. But eventually, it's all the same thing under the hood. There is a theorem called the infinite monkey theorem. It says that if we'll give a monkey a typewriter and an infinite amount of time, the monkey will eventually type the entire works of William Shakespeare. And fuzzers kind of work the same way. It's sort of a brute force approach in which we're trying many, many different inputs in hope of finding that rare bug, which is like the works of William Shakespeare. So a fuzzer is a monkey. Fuzzers are cheap, and they're easy to set up. Usually, you can just reuse the tests that you already have set up before. We can see that with Foundry. And in practice, they are very good at catching some classes of bugs, which are relatively common, meaning that they occur on many different inputs. However, they still don't cover all the states or all the inputs or all the starting scenarios. It can only check some subset of them. Can we do better? I'll give you some motivation for it. MakerDAO have a stablecoin called a multi-collateral DAI. And quite recently, they have found out that something that they thought should always be true about their token is wrong. It was called the fundamental equation of DAI that should tell you what is the ratio between the depth and the amount of tokens that there are. I'm not even going to explain what that equation is. The interesting thing to see is that this is the minimal example to recreate this bug, right? So it's a combination of calling 8 different calls in a specific order with a specific relation between the different inputs. So obviously, you can put in between them some irrelevant calls, and the inputs are not specific, just the relationship. But the chances of us uncovering this with fuzzing are pretty low. So what can we do? If we'll go back to school for a moment, we have all learned the Pythagorean theorem. The Pythagorean theorem was proven to us, and we know that it's true for every right angle rectangle. And we know this without actually checking all the different rectangles in existence, which is basically what we were trying to do with fuzzing. And we were able to prove it using mathematical theorems. And this is essentially what we're going to do with the following technology called formal verification. Formal verification takes your code and transforms it to math, and then tries to prove that math equation. The downside is that if you transform your code into math, you should also transform your tests into math, and we call those math tests specification, or even formal specification, because it's as formal as a mathematical equation. There are different types of formal verification. The two that we're going to discuss are symbolic execution and theorem proving. First, let's look at an example for a specification. This example is written in the Certora verification language, which is the input language for formal verification tool by Certora. If we look at it, we see that it's actually not that different from the test that we saw earlier for the transfer function. So we check the balance of Bob before the transfer, we transfer some amount from Alice to Bob, and we check that the balance of Bob grew exactly by the amount that Alice has sent. What are the differences between this and the test that we saw before? Well, here we don't know what the balance of Bob was before the transfer. It's no longer necessarily 0. We also didn't set up the addresses of Alice and Bob, and more interestingly, we didn't set a specific amount. You can think of it like an X symbol in math, checking for every amount. The first type of formal verification that we will discuss is called symbolic execution. There are several tools on the market that do this. There is the Certora tool that we've discussed before, there is Manticore by Trail of Bits, and there is Mithril by Consensus Diligence, and others. The basic idea of symbolic execution is that we give the specification, which is the math test, and we give the code, and we get 1 out of 3 possible outcomes. Either we get a proof, which is a mathematical proof, that our code behaves as we've wanted to, as we've defined in our specification or our tests. And that's great. That gives us some confidence. Greater confidence than just trying some subset of inputs. Another possible outcome is a violation. And when we get a violation, we get a specific set of a starting state and inputs, which violates what we wrote in the specification. And this is an unexpected behavior, which oftentimes is a bug. The third option is that the tool cannot decide and just times out. Symbolic execution is a turtle. It gives us the maximal amount of protection. See, it covers so much. And again, the big difference between this method and the previous ones is that we have some mathematical proof for the absence of specific bugs. And I also want to mention that just the process of writing what we call the formal specification is oftentimes enough to uncover bugs in the design or the implementation just by itself. However, as a turtle, formal verification is slow. Formal verification, at its core, theoretically, tries to solve what we call an undecidable problem, which means in practice that first, we have to bound what we're trying to do. For example, we're not proving anything for an infinite amount of iterations in loops. What does it mean if, for example, we have a function that runs over an array with a variable length? We will limit it to, say, 3 iterations, 8 iterations, or some limit. What it also means is that it doesn't matter what, we will always have some programs and some specifications at which we will fail. Fail miserably, meaning we will time out, no matter how much time we're going to give. Formal verification will be as useless as a turtle flipped on its back. And this is unavoidable. It will sometimes happen. This is inherent to the technology. However, we see that in practice, this is not the limiting factor. The limiting factor is the need to write those math tests, those specifications, which is hard to do. It's not natural for many programmers. And there is a problem of what happens when the specification is not good enough. If the specification doesn't actually mean what you wanted to prove, or there are some key properties of your code missing from the specification, then it's not going to cover you from bugs. It's the same as tests. If you didn't write the test that can catch the bug, you will not see it. And formal verification is exactly the same in this regard. There is a different technique to formal verification called theorem proving. It's mostly used by runtime verification with the K framework. I'm not going to delve into all the details, as this one is a bit more complicated, but the basic idea is that they use an even higher abstraction. We have a model, a mathematical model of the EVM, and it's already written. You don't need to write it again. What you do, you check the specification against a combination of the code and that EVM model. So two different mathematical entities, and what K is trying to do is to prove that they are actually the same, what we say they are equivalent in math. And this is a very hard problem, so sometimes the prover will need some help, will need some hints from the user, hence why it's interactive. There will be some problems that it will say, I don't know if it's true or not, and the user will need to provide some extra information. So that means that we have three different outcomes, but not the same ones as the ones we get in symbolic execution. One is a proof, and that's actually the same. If we have a proof, then we're happy. There are no bugs in the code, at least like in this specific instance that we've checked. We can also get a violation. However, that violation doesn't come with a counterexample. And now if we time out, it basically just means that we need to give another hint. If we do this enough times, we will eventually should be able to prove almost anything. So to sum it up, theorem proving is like an elephant. It can carry great weights. In practice, it was used to prove very complex systems, much more complex than smart contracts. It was used to prove airplane software or submarine software. And it's also unbounded. Like I said before, we don't need to limit the number of loops or any other things like that. However, it takes a while to tame an elephant, and that's somewhat true too for theorem proving. You need some expertise to know which hints to give to the prover, which is not trivial at all. And there is low explainability, meaning again, you don't have that counterexample, so if the proof fails, you need to try and figure out on your own what went wrong and how, and that's not easy. So we see that writing specifications is a drag. It's not easy, it's hard, it takes time, it costs money. Can we enjoy some of the benefits without writing specifications? So one thing that basically all formal verification provers come out of the box with is the ability to check that some bad reverts in your code don't happen. This could be reverts due to assertions in the code, division by zero, index out of bounds, and all kinds of other things, which is nice, but very, very limited. And that's where static analysis comes in. And there are several static analysis tools in the market. There is Slither by Trail of Bits, and there are tools by Veridice and Consensus Diligence. Static analysis is the process of looking at your code and examining it without running it, hence why it's static. And how it's done, static analysis tools have a set of detectors that are looking for specific predefined bugs in your code. What does it mean? Let's look at this example. This was taken from Veridice's website. So we can see that they check for reentrancy, or check for access to uninitialized state variables, and so on and so forth. There is a list. However, while we're trying to have a one-size-fits-all tool, we know that in some design patterns we actually use reentrancy, and sometimes we actually do access uninitialized variables in order to, for example, save gas. So not necessarily the things that static analysis will complain about will be actual bugs in your code. Static analysis is like a goldfish. It's cheap and it's easy to maintain. Usually You just plug and play, give it as an input your source code, and it will tell you all the problems that its detectors may find. It's also very pretty. It tells you exactly what was the thing it was designed to find, and will explain to you the attack, show you previous exploits, and you can have loads of documentation on every detector. Pretty like a goldfish. However, like a goldfish, it's confined to its aquarium, meaning it will never be able to find a bug that it was not programmed to. If there is no detector for something, then the static analysis tool will never find it. And also, from a practical point of view, these false alarms are a real problem. There are plenty of fish in the sea. This, for example, is me running Slither on one of the simple smart contract codes we use in Certora for testing, and there are several pages worth of warnings or alarms. In this specific case, none of them are actually relevant or interesting. None of them are real bug. So what you gain in simplicity of use, you somewhat lose in that you need to spend some time in weeding out those counterexamples. To sum this part of the presentation up, in practice, each company uses a combination of technologies. It's not a single animal, it's a hybrid animal. Certora uses static analysis to improve formal verification, Consensus uses static analysis to improve fuzzing, and Veritas uses fuzzing to improve static analysis. And there are many more examples, so keep that in mind. Okay, so we've seen all the different animals, and now it's time for zookeeping. How do we know that we treat these animals right? How do we know that we are using our tools effectively to find bugs? One way is to have a human inspect them, meaning you have a person, an engineer, look at your tests, at your formal specifications, and so on, and check if there is something missing, if there is something wrong. Another option is that many tools will report what is the code coverage that they have. And you're probably familiar with this from testing, also from traditional software. We have different types of coverage, branch coverage, and line coverage, and many, many others. However, there is another type which is somewhat less known, which is called mutation testing. And the idea is that we're trying to test our tests. We take the source code and introduce some random faults in it. The code with a random fault is a mutant. And we expect that mutant to fail at least one tool or one test in our test suite. I'll show an example. This is a code of the transfer function that we saw before. It contains no bugs. And therefore, it should pass all our tests. However, we've created a random mutant of it. In this example, we can see that the first line has been omitted, has been commented out. Okay? And we expect that this wrong function that doesn't make any sense should fail our tests. And if the mutant is not failing any of our tests, then we know we have a problem. We know we have missed something. We have missed something in the test, in the specification, or something like that. Certora has a mutation testing tool called Gambit, and it's actually open source. You can go and use it with whichever other tool you want. What are the takeaways from this talk? Different tools, different technologies are like different animals. They behave differently, they have different limitations, different strengths, different restrictions, and different costs. We can see that there is no tool that is strictly better than the others. Each tool has its own disadvantages and costs. And the key to security is to try and combine several different technologies to cover the drawbacks of each other and find as many bugs as possible to secure our code. Thank you. Any questions? Thank you. Can I take it off? I want to be muted. Yeah, it's done.
Test, test. GM.
With the early morning session where nobody turns up.
So like how do you want to take this at like
Well, I think like we have Polygon, blockchain, Web3, decentralized backend, RPC provider. We're basically
articles as well.
Okay.
All right, cool. This one is just slide. Then you can slide it. Thank you. Yeah. So I'm just gonna.
Hi everyone. We're here to talk about Web3 infrastructure. Chose a topic about decentralization versus distribution. I'm from Anchor, head of infrastructure.
Hey guys, I'm Luis. I'm the co-founder of Gelato Network.
Hello everyone. This is Asif from Polygon. I take care of the DeFi stuff at Polygon. Really excited to be here today.
Yeah, so obviously within for Anchor, we do a lot of work to distribute our network. There's a lot of discussion about what does decentralization mean in infrastructure. Obviously, to a certain extent, we are centralized as an RPC provider. We have a website, we have we use Cloudflare, and so on. But we do work very hard to distribute our nodes around the world. So we're in 37 metro areas, 37 different data centers, including third-party providers as well. We are always striving to understand what we can do more to be more decentralized, be more distributed. And so I'm interested to hear what other people's ideas are about their efforts to, or how important decentralization is to your protocols, to your blockchains, what efforts you're doing to do that, and so on.
Yeah. At Gelato, we're also in the business of building the decentralized backbone, backend for Web3 applications, whether they be on Polygon, BNB chain, all of these places. And we also in an eternal struggle to try to decentralize as much as possible, but also being mindful and sort of realistic about the fact that there's a bunch of very good technology out there that doesn't necessarily lend itself to decentralization, like HTTP servers or whatever, but they still have their place in this world, right? Like a website, nothing wrong about that. Not everything has to be decentralized. Although, of course, I think one of the points that I see today still sort of lacking is like IPFS and so on is really cool, but it's not really that production ready, I would say. It's just, people have problems with pinning services and so on all the time. But yeah, so what we're sort of focusing on is having this decentralized backend component. So we're working together with Anchor, with RPC providers. We're working together with networks like Polygon to basically provide a decentralized backend for decentralized applications, because developers always think, okay, the smart contract is my backend. You can like write a bit of Solidity and then just put a front end, a dApp on top of it, and it works. But in reality, smart contracts by themselves are not powerful enough to really, support a lot of like high usage applications. There are some differences maybe, like Uniswap is a very powerful application, but that's about it. Everything else really needs very strong backend components for things like automation, data oracles, transaction relaying at scale, all of these things, account abstraction. And what we're basically trying is to give developers these technologies, like these server technologies, but in a decentralized way, and give them access to this decentralized network of data and transaction execution with as little centralization as possible. And for example, what we can do there is you can use smart contracts to regulate data and validate data on chain. And if that is not possible, then you can still validate the data in a network of nodes off-chain. They have to come to consensus on it. Yeah, but that's basically what we're working on. And one of the things that are also still centralized in Gelato, centralized but distributed, is, for example, the API gateway for our Relay API, right? Like, there's no really good way, I think, to decentralize an endpoint like that. I mean, I'm sure you are researching decentralized RPCs, which is super interesting, but we haven't really seen them yet. Yeah, we also sort of have the same question because, yeah, giving developers a P2P client simply is not as developer-friendly as giving them an HTTP API. That's basically it. And yeah, so, you know, that's where the centralized choke points still are, but maybe they will remain. Maybe, yeah, would be interesting to hear your points on that.
So I think the way we think about decentralization and services is that you can probably verticalize it across. So on the one end of the spectrum, you've got things like the base layer, that is Polygon blockchain, be it our ZK EVM, which will come live on 27th, or our current POS network. And then on top of that, there are a lot of infra layers, be it oracles, be it RPC providers, and be it user-facing applications, be it dApps, or even like these front-end applications you have right now, like things like Zapper, Debank. So I think as you move down this spectrum, UX matters a lot. So maybe things like Debank or Zapper, they can be very well centralized because they are catering to the end user. So I think their UX matters a lot. Maybe then how their backend is decentralized or distributed, because you need like fast access to data there. But I think on the other side of the spectrum, if you talk about Polygon, the base layer, you've got a decentralized set of validators where you cannot afford level of centralization because economic incentives are involved there. And if people will have incentives to be a bad actor, they will. That's what we have seen in last 2 years, last 1 year especially. So yeah, I think it's more about this spectrum and figuring out where you can sort of tolerate some centralization and where you just cannot. Yep.
Yeah, absolutely. No, I think that finding that balance between decentralization, centralization, speed, accuracy, all of these different trade-offs that you have to make when you're designing these services are critical. I don't think there's particularly a right answer about this in some of these cases. You can play it off. I mean, I had a lot of conversations yesterday with people who were saying, look, at the end of the day, how many people really care about decentralization on RPC, right? They just want a fast service, a fast, accurate service. They want one place to go to, and they want to be able to get their data. They want to send their transactions. At the same time, we're not sitting down and saying, that's the end of the story. We've done a good enough job. We work very hard to try and get third-party providers in. There are some privacy concerns for us because we're very, at Anchor, we're very focused on, and we've just rewritten our privacy policy to make it really clear. We don't mine your data. We don't front-run you. We don't link your address with your IP address and all of this kind of stuff. Once we start bringing in third-party providers for our RPCs, we run into this issue that we don't control that anymore. So there are some trade-offs that we have to make there and some understandings about these things.
Yeah, I think maybe the sort of conceptual mistake that a lot of Web3 crypto ideologists make, you know, I also started out being like everything has to be decentralized and so on, and that's true, I think, over the long term, as much should be decentralized as possible, but it shouldn't stop you from shipping something quickly. Most important thing is that we get more users in at a quick rate, and you can't, you know, ask users to use a website that is down all the time or slow or something, right? They will not come to Web3 if that's the case. So I think there's totally fine to make some shortcuts as long as you're not, you know, violating the core tenets of crypto, which is, you know, don't custody the user assets, don't have one guy or one company be able to rug everybody and so on. So as long as this is still true, which you can regulate in most of the cases via smart contract, you know, if your front end is still centralized, if your API is still centralized or something, that's fine. You're a business. you have every incentive for it to be available at all times to users. But then again, right, we want to be an open global economy, and there are a bunch of people, I don't know, maybe in Iran or so, that are good guys and girls, and they want to build a reliable application, and they don't want to be OFAC censored or something, right? So it is important, I think, in the long run, but you shouldn't try to shoehorn decentralization into something that isn't ready yet. So I think we should all on our roadmaps have decentralization plans for everything. We should invest in decentralization where it's not here yet, but we should still ship with whatever works today and then progress there with time.
For sure, totally agreed. I think what matters here, I think totally agreed that early on maybe you can tolerate some trade-offs because you want to offer services to people, you want more people to come in, you want more users. And maybe in short term, if that happens, maybe at the expense of decentralization, I think that's a valid take. But I think you need to have a very, very clear roadmap as to how you're going to go about things in future. So let's say if you think about Polygon, when we started our network, the POS chain, which has its own set of validators, so it does not borrow exactly from Ethereum layer 1 security. But I think back then we had a very clear path that we want to ship a product upfront. We want to get users in, we want to offer dApps. But at the same time, we invested a lot on the ZK capabilities, and that is why we're going to now ship the ZK EVM mainnet beta on 27th. And it's been a lot of hard work behind the scenes, and it's been a lot to sticking to this idea that we want secure, decentralized infra for the developers. I think even if you talk about ZK EVM, right now, there would be a centralized sequencer because we just released mainnet, but I think there's a very, very clear path as to how we want to then decentralize the sequencer as well. So there's something called proof of efficiency, which will use Matic token and which will then enable independent, permissionless sequencer runners to come into the network to participate, to become sequencer validators in a way you can say. Sure, I think for sure you can tolerate like centralization in some manner for some short amount of time, but you need to have a very, very clear path as to how things will look in future. Yep.
Yeah. No, I think there's a big challenge for ZK. I mean, essentially, I actually started in the crypto space back in 2018 with Horizon, which is a clone of Zcash. And yeah, that was more decentralized, but not on the validator side. This was all GPUs and so on like that. But as I've worked with Anchor, it's definitely about that. It's a challenge that all of the sequencing, it's all off-chain. It's all happening somewhere else on somebody else's computer. So to an extent, the privacy is compromised, potentially compromised. And so definitely decentralizing that is a very important feature, I think, for moving forward with that stuff. Yeah.
And I think the panel title talked about distribution versus decentralization, so maybe a word on that. So I think distribution is really a question of modern software deployment architecture. And really, you want at a certain scale, if you have a ton of usage, decent loads, you want your system to be distributed because only then can you ensure high availability across the globe, uptime, all these things. And yeah, so that's, I think, really important. And many companies, Web2 companies, they're all distributed server companies. And in some manner, they're also, I think, decentralized sort of internally. They use decentralized architecture, sometimes P2P. I'm sure Amazon, AWS uses P2P and so on, right? So you can actually, if you zoom in, you can be a centralized company and still leverage distributed and decentralized technologies to great effect. But in Web3, the decentralization question, so distribution is not a question, like it's do it or die pretty much at some scale. In Web3, decentralization means not just one company having the power, right? Not one company can go out of business Not one company can shut down your application or servers. It's really about that. There, I think we can, all get inspired by the Ethereum protocol, by the Bitcoin protocol. And at the end of the day, what we're trying to build here is not like companies that control a network, like fake networks, right? But what we actually want to build is self-sufficient digital economies that are decentralized. So we have these amazing digital assets that are digitally transferable and everything. So now what we need to do is we need to match, for example, in Gelato, the demand from application developers for server power with the server power distributors and so on. And all of this should be matched in a self-sufficient on-chain protocol where the exchange of payment and so on is all encoded, so that eventually as Gelato we can also step away, we can go out of business or whatever it is, or turn crazy, and that network will still be self-sufficient, it will still have an economy that supports a certain amount of node operators, so that any one of these can go out of business and you as an application developer can still sleep well at night knowing that your app will be served. So I think that's like the big difference here as compared to decentralization in Web 2, where it's really, yes, it's decentralized technology, but one company makes the decisions. Here it's about, there's a protocol that regulates this marketplace, and it's always there. You can join it permissionlessly, you can exit it, and it still works. The economics are right. So yeah.
One company or one country, I think, is also the other question. Certainly for Anchor, as I said, we have 7, 8 different providers. We don't use cloud at all in our RPC business. We only use bare metal. We are distributed in that sense. We have lots of data centers all over the place. One of the reasons, obviously, to move away from using AWS as we had done previously was about price, but the other one was about the ability to not be censored in that way. So if AWS gets the mandate or they're being told no more crypto, what happens then, right? So I don't know if that's a feasible situation, a real situation that will ever happen, but who knows? I mean, regulations have been coming down on various crypto companies, and anything could change from day to day. I mean, we're still a US company, we still have to abide by US law, but at least from the infrastructure perspective, we are distributed. Yeah.
I think now we have been speaking a lot about the infra side of things, which, and specifically like RPC and blockchain layer, but I think would love to talk more on the Oracle side as well, because if you talk about DeFi, be it lending markets, perp markets, oracles are a big critical piece of the whole DeFi stack, and I think the last 1 year saw a lot of perp volume happening on chain. So be it GMX, which has done like almost 100 bill. Gains has done like 25 bill on Polygon. Sin Futures has done like almost 20 bill on Polygon. But if you think about oracles and their centralization, in a way, if you talk about order flow auctions, the whole story that started around 1993, wherein these brokerage firms started selling order flow to these market makers. I think if you think about oracles, in a way, oracles are the way to realize order flow auctions. And in a way, a sort of an MEV can happen on an oracle layer. So let's say you have an oracle provider, there's some bunch of data providers, and they also happen to be market makers who are, let's say, trading on CEXs. Now, if they are providing prices to the Oracle network, in a way, they control the price that is existing on chain. And in a way, they can then front run the perpetual transactions that are happening on chain on Oracle level. So I think Chainlink's been doing really well. But there are some trade-offs there as well, because on some of these price feeds, the heartbeat or the deviation may be too conservative. So for some of them, it may be like 0.5% heartbeat, 0.5% deviation, something like that. And some of these newer oracles take data directly from these providers who may be market makers. So I think like as a whole DeFi community builders, we've got to think about Oracle decentralization and this whole Oracle extractable value in a way, because I think this will be like a key thing, because now perps have significant volume on chain, which I think was not happening like 2 years ago or even 1 year ago. Yep. So would love to know your thoughts on the Oracle side of things as well.
Yeah, I totally agree with that. I think one of the unfortunate situations that DeFi finds itself in, that is always a bit hushed over, like it's not really addressed that much. It's becoming more now is this, vast monopoly that Chainlink has. I think they got there deservedly, right? They have amazing technology. They pushed really hard for this, but they bear some resemblance to a sort of 90s Microsoft, super aggressive sort of monopoly company. And I think that's very bad for DeFi, right? Because at the moment, if you look under, what DeFi is, under the rug, no pun intended, then you'll see that a lot of it is really just all reliant on Chainlink. And I think we need to see a lot more innovation there, a lot more competition. And hopefully some new Oracle designs that are also much faster, that's needed for a lot of applications. I talked to the guys from Redstone recently. It's, I think, a new project. There are some cool designs, like Oracle-less design is also an idea, right? Like lending markets built on Uniswap v3, like TimeSwap. But they usually, I think, have some restriction in the sense that they have to be sort of fixed time, and that doesn't really translate well into our world. But these also exist, so Oracle-less solutions are amazing. I mean, Uniswap, for example, okay, they have their own TWAP oracles, but that's a very cool on-chain thing that is really decentralized. But yeah, I totally agree. I think we need to see a lot more innovation there on this front, and not just from one company. And we will see that in the coming years. And DeFi will be better afterwards.
Okay, so I think we're heading up to our last 4 minutes. Do you guys want to talk about any future plans for any of your products that you're working on towards decentralization, distribution, etc., anything like that?
Yeah, so at Gelato we right now have 3 services in our network that we offer. One of them is Automate. That's the original one that we sort of invented. We were like the first smart contract automation protocol. And there it's already pretty decentralized because it relies on-chain logic. So as an application, you have full control over the data flow in your application on-chain. And actually, as of recently, we finally removed a centralized technology, RabbitMQ, and swapped it for libp2p, a decentralized technology. And we're able to onboard the first node operators to our network. So it wasn't just us running the Gelato nodes anymore. It has been now, staking facilities, for example, and we're talking to many others. So at the moment, Gelato node operators are in a private beta. If you are a node operator, please contact us. And our long-term vision there is to, by 2024, 2025, be a completely open permissionless market so that anyone can spin up a node similar to what you can do in Ethereum. Just have to stake some gel and off you go. And for relaying, it's similar. It's also using the same network. So as we add more node operators, it will become more decentralized. But there you always have decentralized choke points, like an HTTP gateway, like as you know from the RPC business. And last year, end of last year, we shipped our Web3 functions, and that's our own sort of first foray into, I guess, what you could call oracles, where we're now allowing off-chain data, APIs, and so on to also be used. Again, adding node operators, adding staking. It's coming, and just working at it, being patient, but never losing sight of the target.
Yeah, for sure. I think for us, like the biggest focus area right now is definitely our ZK EVM network, which will be coming live on 27th. All transactions, everything, and just making sure that this networks run smoothly is the best execution layer for DeFi, NFTs, gaming. Yep.
Yeah, I think it's interesting to think about potentially reducing the need for some of these decentralization efforts by protecting the transactions as they go through and things like this, so that it's not, so that the potential for censorship and tracking and so on like that is less. Certainly within Anchor, we're working. We did actually at one point release a third-party node providing service. We were working on this hard as a project. It got sidelines, but we are starting that back up again, and that's certainly one of the focuses for us, is to get third parties, individuals. We will focus initially on a vetted group of professional people or professional companies that are doing RPC and do that. And also we're working on version 3 of our network, which is fundamentally, without releasing any more details, much more decentralized than the current system that we have with Cloudflare and so on like that. Cool. Well, I think we're at time. Thanks, everybody, and have a good time.
Thank you.
Thank you, everyone. Take care.
Check this.
I can just use the podium as well.
All right. Hey guys, hope you're doing well. I like this is a full house today. All right, so I'm Ali. I'm the founder and CEO of Magpie, and today I'm here to talk about the importance of cross-chain infrastructure in DeFi adoption. Let's look at the state of ETH right now. Ethereum has established itself as the global settlement and security layer. All of the builders working in the space, all of the innovation that's happening has essentially put the ETH killer narrative to rest. Instead, the focus has been, how do we scale Ethereum? How do we lower the costs? How do we increase the transaction speed? And all of that we're doing to onboard the next billion users. I think that's become much of a slogan for most protocols, that how do you onboard the next billion users to DeFi and to crypto? I read an interesting article about from a senior researcher at Ethereum Foundation by the name of Danny Ryan. He said something to the effect that L2s will inevitably become the face of Ethereum. L2s or layer 2s will how most of the users, a vast majority of users, will interface with Ethereum. They will operate within different layer 2s, bridge across, and use applications that are specific to specific chains. So layer 2 scaling improves transaction speed, lowers costs, and allows for app chains, specific chains for specific applications. However, there are limitations to the proliferation of L2s. A lot of L2s has resulted largely in fragmentation of liquidity, fragmentation of data, and that in turn creates a poor user experience for users and for builders as well. Fortunately for us, there are a lot of smart people working in the space. They've been working since the early days of Ethereum, building the key infrastructure, building key DeFi primitives in order to drive new user adoption. What we've seen historically is that as you have new infrastructure being built out, new DeFi primitives being launched, a new wave of users and builders is onboarded within DeFi or within the blockchain space in general. This slide visualizes that to a certain extent. Obviously, we cannot list out all of the protocols, all of the infrastructure that have been built, but some of the key infrastructure providers like Etherscan, the Graph protocol, when they made their services live, it allowed for builders, it allowed for users to query on-chain blockchain information, which previously was very difficult. DeFi primitives like lending protocols, AMMs, DEXs, all of these have helped build a new wave of innovation where builders are able to build on top of those and users have something more to do other than, well, trade and buy crypto or ETH. Further, we see layer 2s like Optimism, Arbitrum, Polygon that have certainly led the way in driving further adoption, be it NFTs, GameFi protocols, and finally we have cross-chain infrastructure, bridges, interoperability protocols, cross-chain liquidity aggregator, the likes of LiFi, Socket, and well Magpie. So new primitives, new tech drives new users consistently. So we at Magpie, too, are working on cross-chain infrastructure. We provide a cross-chain liquidity aggregator that allows users to move any asset to any asset across all of the chains that we support. We further allow for people to access blockchain data, analytical information across different chains, and we're essentially dedicated to this mission to build key infrastructure that drives the next wave of adoption and innovation within the space. That's pretty much it from me. We're pretty bullish and we're pretty excited about the area that we're working in. We obviously certainly have a bias, but curious to hear from you guys what you think the next catalyst will be. Will it be a super app that drives innovation? Is it a bunch of different applications, GameFi projects, app chain specific, well, chains and applications? So curious to hear from you guys. That's it from me. Thank you.
one is yours? Next?
Yeah.
This one?
Quickswap, yeah. No. Where is?
No, Quickswap I've not got. I've got Security. If so, yeah, that's why it's not.
I can send it to you. Like, where do I send it to you? I send it to the, like,
If you, okay, you can just open a WhatsApp on this and just download it. Like, wait. This one. Yeah. Yeah. Just open, download the file and then log out.
Sure. I'll do it.
I thought because everyone's is here, that's what.
No, I send it to the organizer.
No, there's yours is which one? Macro.
No, mine is like.
Okay, yeah.
Yeah, that's
So
what.
I'm here.
Yeah. So now Quickswap, right?
Quickswap.
Yeah.
Oh, perfect. Okay.
Yeah.
Then this. What about this?
That's after Quickswap is here.
Okay. Perfect. So we.
So sorry. Okay. Yeah. You have or your presentation is also there. I think over here. Okay, just 1 minute. One minute. Just wait. Yeah. Which is yours?
Device implementation.
This one, right? Yeah. It's
Try to open it, please.
Yeah.
Put a second. The third one?
Third one?
Yeah, 1 minute. Yeah.
It's proper? Okay. Thank you.
Yeah, okay. Is there a way like that I can read this?
I don't know. Let me see. Nope.
You can't, man. Like in presentation.
Sorry?
You can't do that. Like it's like it's like secondary notes.
Those are secondary notes.
Okay, no problem.
Yeah.
So I will read the secondary notes on my computer.
Yeah.
Okay,
Okay, no, finally.
you pointed out and I written my secondary notes.
Yeah. I don't know whatever that is. New window. It's a web. Thank you. Yeah.
What is this? It's my hype music. Look. Yeah, it's there, man. Yeah. How do you start the presentation, man? How do you start the presentation?
It's all good?
How do we start the presentation? I don't get it.
It's Canva. Don't you have this or something?
Hey. She created that, so she should be able to.
That's what.
You created this. Like, how do we start the presentation in Canva?
It's here.
Oh, okay.
Yeah, you can just now tap on this one.
Thank you.
Yeah.
Right.
You want to use the podium? You'll be here, or you want to have a wireless microphone, or you want a headset? It's all up to you.
Wireless microphone's better. Yeah.
Yes, this is the. That's all.
Thank you. Actually, this is fine. This is fine.
All right, everyone. Thank you for coming. Want to start by giving a thank you to all the people who organize this ETHDubai every year. This is a great event. We meet a lot of great. Is this mic going in and out? We meet a lot of great people, so want to give them a round of applause. Thanks, organizers. So I actually won't be going by this presentation very much. We'll just be talking about maybe some more fun stuff. I'll probably flip through it. You could read it if you want, ignore it if you want, whatever. So I want to start by talking about, I want to rename this actually talk to Standing on the Shoulders of Giants. So going back billions of years, humans have evolved and stood on the shoulders of our ancestors from bacteria to now. In tech, we stand on shoulders of giants as well, going back, you know, in our industry to like cryptography of the Enigma machine in World War II, and then later on with Adam Back's Hashcash and DigiCash, eCash, eGold, leading eventually to Bitcoin. Then Vitalik stood on the shoulders of Bitcoin, had the vision for a Turing complete virtual machine, and that's why we're here today. Moving from that, Polygon found a way to scale Ethereum with its Plasma and POS chain, which was, as Vitalik said, kind of the quick and dirty solution to get something out and stop people from leaving to quote-unquote ETH killers like Cardano, et cetera. And then the next kind of iteration was now rollups with optimistic rollups, Arbitrum, doing great stuff, optimism, et cetera. The next iteration is Polygon ZK EVM and in general ZK rollups, which are, in my opinion, the holy grail of scaling. So I'm wearing my ZK EVM, Polygon ZK EVM shirt. I'll be wearing it all month. It might get a little smelly, but we'll be wearing it until ZK EVM launches on the 27th. Similar to my, if anyone remembers my bear market beard from the last bear market I had for like over 2 years, I looked like a rabbi. So going into what this is supposed to be out here, let's scroll a little, let people maybe read, yada, yada. So now Quickswap is standing on the shoulders of giants again. We started by standing on the shoulders of Uniswap, taking their V2, seeing a great opportunity to fork it and bring it to Polygon so people could do the same great things they did with Uniswap, but on Polygon with, you know, sub 1 penny fees. We saw the volume and the amount of users go like explode, right? Quickswap was doing more daily transactions than all of Ethereum's 50,000 dApps combined at our peak, and that was great for society, great for people in third world countries, the unbanked, to be able to come and trade, you know, for under a penny. Then Uniswap came out with V3, did a great job with that. We came out with our V3, thanks to our partners Algebra. And then now our most recent thing that we're going to be doing is standing on the shoulders of GMX. So GMX has proved to be an incredible product market fit. We're seeing, I mean, crazy volumes for a bear market. This is what the world wants. Going off of this slide here, there's a big appetite for people to get off of sexes. Wish this was a little taller. To get off of sexes and come do DeFi, not your keys, not your coins. We've talked to probably 50 funds and banks in the last few months about Quick Perps, and the appetite for this kind of stuff is incredible. People don't want to keep their assets on exchanges anymore. That includes crypto exchanges, and also now we're seeing a bank implosion, right? You know, Bitcoin originally went from $40 to $250 when the Cyprus banking system was collapsing. So there's a long history of people, you know, learning that not your keys, not your coins. Sometimes people start to forget, and it takes big events like what's happened, you know, in the last week with literally, you know, America's banking system going into utter turmoil and them having to do, you know, this emergency bailout. So yeah, Quick Perps will be using the GMX model. Very similar. It's pretty simple. It's GMX, but for Polygon. The same thing we did with Uniswap originally. We're going to do this now with GMX. There's some key differences. We will not make a new token. There will not be a QMX token. We will instead take the revenue from Quick Perps and burn it. So the margins on GMX are pretty incredible. There's a lot of people doing the same thing on other chains with a lot of success. I don't know how it has not been done on Polygon yet. We're glad. We'll take advantage of that. But if you look at like the volumes on GMX recently, they're hitting 200, 300 million a day in a bear market. What we're seeing is in traditional finance, derivatives are 20 times the volume of spot globally on traditional. We've seen a pattern of this, and it's transitioning rapidly. Let's scroll a little bit here, let you guys read if you want. So we believe that derivatives will dominate DeFi, that eventually it'll be just like traditional finance and CeFi with 20 times the volume of in different types of derivatives. The best product market fit we've seen so far is the GMX model. So that's why we're adopting it. Let's see. Oh, I want to also talk, let me see, do I have any time? Maybe, I don't know. I want to also talk about our V3. We launched our V3 after Uniswap came to Polygon with their V3. We launched ours, and it's pretty incredible. We launched our Gamma liquidity management software. So if you're used to V2 and you want to try V3 but don't, are intimidated by trying to manage the ranges and change the ranges and impermanent loss and all that, we've actually got automated liquidity management software called Gamma, very similar to like Arrakis you might all know from Uniswap, or not made by Uniswap, but in conjunction with Uniswap, built on top of Uniswap. So our Gamma, right now, the APRs are pretty high. We're subsidizing a transition from our V2 to our V3 with some incredible rewards. We're giving about almost $1 million a month to help encourage people to transition from our V2 to our V3. We want to basically vampire our own V2. So you have rates like ETHUSDC, I think today is 110% APR, and that's coming from trading fees plus farming rewards. ETHDubai is 130% today, I believe. If you want to check, you can go to quickswap.exchange and the farms page. And then you have like USDC, USDT at, I think, 17% today. So yeah, cool stuff. I want to talk about, last thing I want to talk about is Polygon ZK EVM. This is coming this month, I mentioned earlier. Pretty incredible that we're going to witness this. Vitalik said that this would take 3 to 5 years, about 2 years ago. But the Polygon team, in their foresight, started building this rapidly, acquiring the best minds in the space from, they acquired the Mir team for 400 million with their proofs technology, basically the furthest in the space in proofs. They acquired Hermes for 175 million and then Maiden for 75 million. They put these teams together, let them compete a little, reconfigured them, took some of the best pieces from each, and that's how they built ZK EVM and some of the other great chains that Polygon is building. So a lot of people, final iteration, which will make all these different chains, whether they're the Matic POS chain, ZK EVM, Polygon Nightfall, etc., or if they're application-specific chains, I think it's public knowledge that DraftKings is making their SuperNets chain. There's a bunch of big institutions that need the throughput, need massive throughput, so they're going to have their own application-specific chains secured by the Matic Validator Network, and then ultimately secured by Ethereum when we transition to ZK EVM. So really excited for this. Everyone here should be. This is a huge step forward for Ethereum. And everyone here, ZK, EVM, and just in general, ZK rollups are the holy grail of scaling in my personal opinion. So really excited to see that happening on the 27th of this month. Thank you guys, everyone here. And if you want any more information about any of this, come to the Quickswap booth. Thanks, guys.
Hello. Hey everyone. This is a small lightning talk about how the Web3 and Web2 security approaches are similar and what's the good and the bad of Web3 security. So a bit of a background. My name is Omar. I'm a co-founder and CEO of the company Decurity. We do security audits and develop the security monitoring solutions for the smart contracts. And all of us come from the traditional cybersecurity background. We've been developing the high-load firewall systems. We've been doing penetration testing and such. And so we see a lot of analogies and what's similar and not similar between the approaches to cybersecurity in the decentralized world and the centralized world. So a very extremely high-level scheme of the security cycle is as follows. So there is a stage before the product is live and even before the product has started development. So at this stage, it's important that the engineers and even the users, the future users of the product are aware of the security threats and how to build the secure products. It's also important that the developers understand the risks that are associated with this product, and they have to design the system in such a way that that those risks are not realized. So during the development of the system, there are audits, there is testing, there are various procedures implemented in the development pipeline that have to be done to ensure that at each sprint, at each stage of the and milestone of the development, all the security properties are good. So the third high-level stage is the production. When the product and the system is finally live, then it can get attacked. So obviously, at this point, there have to be some kind of a monitoring, and there has to be some kind of an incident response. So we have to know when something happens, and when something happens, we have to react to this. So in Web 2, this maps to a lot of different frameworks and tools that are used for security. So before the product is development, you can just pull up any standard which is relevant for your industry. For example, a WASP application security verification standard. You can pull up some methodologies like Microsoft Stride. There is secure development lifecycle. There are loads of different approaches, including even ISO 27001 and other certifications. There are many tools where you can draw the threat models and to visualize how your system will work, how the data flows in and out, and what are the possible threats for it. And during the development, you can use hundreds of open source tools and a lot of commercially available products that have been on the market for 10 years or more for static analysis, for third-party dependencies analysis, for the dynamic fuzzing and scanning of the applications. And also there are hundreds of penetration testing firms, and there are different competing bug bounty platforms and vulnerability management solutions that scan your network, not just the applications. And during the production, there are intrusion detection systems, intrusion prevention systems, web application firewalls that can detect threats or even prevent them. And there are, of course, security incident and event management systems where the security operations centers can look at the dashboards of those CMs and see the data coming from all the security tools and monitoring tools, and to react accordingly when they see that something's happening. And when we try to map those stages and those types of products and frameworks on Web3, there isn't much actually. And it's hard to come up with like top 10 products in each category because there are not even 10. Starting from the awareness, there are some courses on smart contract security, but there is no like an agreed upon standard for everyone. There are some manuals and guidelines scattered across the GitHubs. There are, I think there are no big courses and guidelines about the decentralized systems in general, the security, not just the Solidity smart contracts, but the general approach to securing the decentralized systems. Also, when it comes to threat modeling, so if you want to model how your protocol is going to work, how the tokenomics are going to work, and how the composability with other DeFi protocols is going to work, and what would be the roles of the accounts in this protocol. So this is governance, this is the owner, this is a user. So how all those entities are going to interact. There are only a few tools that you can use, so there is no unified approach on how you are going to model the threats. And when you pull up any documentation even of the major protocols, you can see explanatory diagrams where you can look at and understand, okay, these are the dependencies of this protocol, like they're relying on, for example, I don't know, on the stability of USDC, and there are these roles, and this role is protected by the time lock. So there is no trustlessness in this sense. So during the development, you can use some static analysis tools, but most of them are very hard to use. So it's more, those tools are mostly developed for the auditors, by auditors for the auditors. They're not really production level. They're not mature enough to be used in pipelines without an input from the security engineers and auditors. There are lots of bugs, of course, and the coverage of those tools is quite low. Maybe the most developed part in this cycle is audits, because there are lots of audit firms, but still, even after those audits, the projects get wrecked. There are also bug bounties, but of course there's not much competition between the bug bounty platforms. Obviously, this field is also not as developed and as in Web 2, where we have a few multi-billion-dollar corporations that provide the bug bounty platforms, and there are literally tens or even maybe hundreds of thousands of people who participate in those bug bounties, and they create automation tools, their own tools, to cover all the bug bounty targets there are on those platforms. Even though the bounties themselves are huge in Web3, only a few people could get those huge bounties. For the most, it's not a big deal. And during the production, again, there are some developments. Many audit firms, including ours, are trying to develop monitoring solutions. But again, there is no like a leader in the space that everyone uses, or a few leaders, as in Web 2, where there are CM systems that are used by thousands of companies all over the world, and there are integrations of those systems with all the data sources. In Web 3, there is no such thing as security operation centers. There are war rooms, so-called war rooms in Telegram, that gather up when something's happening, but there is no really a business that provides such a service. Not necessarily a business, it could be an internal blue team, like in the Web 2 corporations, in the banks and such. So there is much to be done in this regard too. So to summarize a bit, the bad in the Web3 security, as I see, is that for the same classes of solutions, there are no really mature products on the market, so it's very early. And all the tooling, including the development tooling and the security tooling, the open source tools are very buggy and rudimentary. Many of them are developed by one person, literally one person develops it for years and no one else contributes to it. And apart from that, the user adoption and the UX security is also unsolved problem, as you may know, in the crypto space. But there are also good things, as I can see them, compared to what I can see in the Web2 security. So first of all, the audits are much more transparent. In the penetration testing field, the companies don't publish their reports. It's a very uncommon practice. Mostly, they can share the executive summaries of the reports with some parties, like the regulators or big clients, but mostly they're not published. In Web3, on the contrary, the reports are mostly published. It's much more transparent approach. Also, there is an adoption of more complex and novel approaches, such as formal verification and zero-knowledge stuff in the Web3. For example, there is some development in the zero-knowledge bug bounty field. I don't know if it will work in the future, but at least something's done in this regard too. And also, to defend a little bit this field, of course it's a very new field, and all the old tools that have been used in Web2 cannot be directly applied to the technology stack in Web3. So all this is understandable. So too long, don't read. My point is that we have to learn the lessons that the traditional cybersecurity gives us. We have to dissect the methodologies and approaches that are already implemented there, and we have to transfer them to Web3, because the structure of the threats is more or less the same, although the technology stack is very different. But of course, we don't need to rely on the legacy, on the complex regulations that are in Web2. They were created back in the 80s or 90s, when the threats were completely different. That's it. This was my main point and the lightning talk about the Web2 and Web3 security. Contact me if you want to talk more. Thank you.
Show me. Okay. Yours is.
Do I have
what?
to press?
Yeah.
Can you?
Yeah, just 1 minute. Which one is yours again? The security, right?
Yes. No.
Incentive.
Incentivizing climate action.
Yeah. I'll put it afterwards. Yeah, you can.
Show me.
Yeah.
Okay. Because I want to put this here, so I read the notes.
Okay.
Can you?
Yeah, that's enough. That's enough? Yeah. So that you don't go on the keyboard. So that's okay?
No. Oh.
Yeah, that's why I was saying.
Yeah, I get it. Okay. Hello, everyone. My name is Giorgio, and I have the pleasure to represent here KlimaDAO, and which is a protocol that I hope you know. I'm one of the founders. My nickname is The Lawyer altogether. I wanted to share something with you that you might not know and you might find quite shocking, but I also would like to show you our solution for this big challenge. Humanity is emitting too much carbon dioxide and other greenhouse gases, which is accelerating the rate of climate change. So therefore, unless we radically reduce how much CO2 we emit, we reach a point of no return where we can reverse the effect of the climate change. The UAE, the place that is hosting me and I'm very grateful to be, is a significant contributor to global GHG emissions with the landmark buildings such as the Burj Khalifa and the hotel sector in Dubai, which alone emits like 1.2 million tons of CO2 per year. So it's like a very, very important issue that the UAE is trying to solve and is like committed to solve in the next years. One of the most promising tools to bring the global GHG emissions under control is the voluntary carbon market. So the voluntary carbon market is also like nicknamed VCM, and it has like different like derivatives. The VCM enables companies and individuals that want to take responsibility for their carbon emissions to drive funding to verified carbon credits projects that do good for the planet by removing or avoiding the emissions of carbon in the atmosphere. So as you see, there are two kinds of carbon offsets, so also called carbon credits, which some they focus on removal and some on reduction. So for instance, like removals can be afforestation, reforestation, ecosystem restoration, while reduction would be just like trying to avoid, so capturing the carbon emissions or like forest conservation or like renewable energy, which is like a very, very important topic, especially in countries like here where we have a lot of sun, of course. So to avoid the worst effect of the climate change, the VCM needs to scale up by a factor of 15 times by 2030. So I'm pretty sure that you at least heard more than once this date, because many, many countries, especially in the GCC area, they have an agenda in order to getting better at the emission and carbon capture in 2023. However, let me walk you through the challenges that we have stopped, have stopped this from happening and how us at KlimaDAO we're solving these challenges. So traditionally, the VCM, it's low, it's a disaster, it's just very, very difficult to access. The carbon credits that you purchase pass through like layers of middlemen who uses telephones, sometimes even fax machine, and I'm not joking. As carbon credits purchaser, you might have to wait anywhere from weeks to months to complete your offset. It's totally inefficient. Like if I tell you now, try to like buy even 100 or 1,000 carbon offsets, is going to be a nightmare for you, because like you need to call like a broker. The broker needs to answer to you because maybe they have like opening hours. They need to find a project for you. They need the way that you pay. So, bank wires takes time. So it's really, really inefficient. With us at KlimaDAO, we revolutionized this market by building a transparent, open, and public infrastructure so anybody can use with no hoops to jump through. In the on-chain digital carbon market, so VCM, we call it DCM as digital, carbon credits can be purchased and retired like instantly with your credit card or with your MetaMask. Traditionally, the VCM also has been economically inefficient because like carbon credit passes through many, many layers, and every middleman adds also like a bit, because everybody has to, gain in fees, and it can arrives up to 400% or 300% depending on the kind of project in excess fees. With KlimaDAO's infrastructure, we have almost near like 0% fees, and so therefore we manage to provide the best pricing available for carbon offsets. Another thing that is very, very important is that like the traditional VCM, it's like totally opaque. It's very difficult for like a person which is not an operator or a broker to understand which kind of project has like a true impact and which kind of is the right price for the project itself. So it's, you know, these kind of things are a huge challenge, especially for people that, you know, they want to get closer to this kind of market, but they have difficulties in understanding how much they should pay, for instance, the carbon credit. So a lot of information are lost and obscures, and at this point, the trust is lost. So with us, KlimaDAO, our tools enable to make your climate actions publicly verifiable, because we built like many tools that allows you to check the liquidity, the availability, the kind of project, and therefore also the price. This is, you know, one of the nicest things of the blockchain. So let me tell you more of what we did so far and what is the biggest impact. So we launched in October 2021, 18 October 2021, unforgettable date for me, of course. And since then, we accumulated over 18 million tons of carbon in our treasury. As I told you before, UAE, the hotel sector is 1.2 million, okay? So we accumulated 18 millions. We are one of the largest holder of carbon offsets in the world. And of course, the biggest of, you know, tokenized carbon. Anyway, we've become the top market facilitator for digital carbon. The carbon credits that have been brought on chain are issued by hundreds of projects that transform the energy grid, protect forests, and have a range of other benefits for community and our climate. We have over 100 clients across the multiple sector like technology, such as Polygon, which is one of the biggest supported and like biggest offsetter, finance, Liechtenstein Bankers Association, aviation, Fly Air and President Voyage, and more that, you know, for instance, also Mark Cuban company uses our tokenized offset for offsetting his emissions, which they use constantly and are using our technology in order to fulfill their environmental goals. As you see, we also have like quite a big attraction of wallets and community. One of the most important things that we did, we're close to the end, we have built a carbon dashboard that is the leading source of digital carbon market information. As I told you, everything is transparent. We provide a bird's eye view of the digital carbon market. With like this platform, basically, you can find all the data related to carbon trading, retirements, and issuance on on-chain carbon. We see that over 25 million of carbons have been tokenized so far. This is the equivalent of the emission by 38 million round-trip flights between New York and London. 38 million round trips, so incredible. The liquidity available on-chain is now far greater than any other single liquidity source in traditionally voluntary carbon markets. But we don't do just this, but we also do integration that are good for Web 2 and Web 3. For instance, we have built something called the Green Fee Tech Stack. This enables any DeFi project to build sustainability into its core functionality. SushiSwap, for instance, is one of the projects that did this. So the carbon offset source from KlimaDAO can be automatically offset every time that a user executes a swap on SushiSwap. Let me give you just like a quick insight. Every time that you, of course, use the computer, you're using electricity, so technically there is an emission, or there is a consumption. And even if like now Ethereum is proof of stake, and even if like Polygon is proof of stake, there is still like a small consumption. So with this integration that we created, basically, we allowed all the people to do their part automatically, just with a click of a button and like a less than cents for doing so. Anyway, there is still a lot of work ahead, and we launched 1.5 years ago, as I told you. Our organization unites talents for over 50 contributors all over the world, so a total of 75 people. And everyone has a deep experience in carbon markets, technology, and business strategy and execution. So all the 50 contributors to our communities of near 10,000 members are all passionate about fighting climate change and blockchain. Our mission is to provide and scale up the transparent, neutral, and public digital carbon infrastructure to accelerate climate finance on a global scale. So I thank you so much for your attention. I hope that you liked it, and I hope that you're going to check our protocol, because we are really care about the planet, and we really think that this is one of the best solutions in order to help also the next generation and our actual generation to do more and to do better. Thank you so much.
Where are you in this list? Like, which one? Just 1 second. Next one. The glitch to fake you to So he was before you, right? That's right. And then the glitch is there, right?
Yeah, that's me. Just give me 1 second.
The HDMI you put?
Yeah, I have it.
You don't have any video, right?
No, I don't. Okay, we're ready to go. Hey everyone, I'm Bartosz. I work at Haken as blockchain layer 1 auditor researcher, and during the last 10 months I found around 50 critical issues in various blockchain projects. And today I would like to talk to you about one of them, a very interesting one, a critical issue in Binance proof of reserves. But before talking about the bug, let's talk about the proof of reserves. So as you probably know, after FTX collapse, everyone started to talk about proof of reserves. The early version of the proof worked like this. An exchange creates a list of all the user assets. They ask a trusted auditor to verify it. And later they release a service which allows you to check that your assets were included in the audited list. This implementation works fine, but actually there's a way to make it even better, and it's by using zero-knowledge proof. By using zero-knowledge proof, we can automate the whole process. We won't need an auditor, and we can basically create a real-time system. And that's what Binance did. A month ago, they announced their own version of the proof of reserves, which is using zero-knowledge proof, which allows them to create a proof that all user balances are correct, there were no negative balances, and all the users were included. And all of this without revealing any sensitive information about the users and their balances. But there is one problem with zero-knowledge proof. It takes a lot of computer power to compute it. So in case of Binance, it was almost impossible to create a proof for 50 million of users, so they decided to create an optimization. In their optimization, they decided to create batches of 864 users and later connect the batches and later connect all the batches to create the final status of proof of reserves, telling how many equity, how many debt they have, and what's the base price of the tokens. So they needed to connect all the batches with each other, and to do it, they use the following formula. Total equity plus total debt plus base price. In programming, we call it bit shifting. It's just optimization to store all the information, all the free numbers in one big number. So, for example, in case of total equity equal 10, total debt equal 5, and base price equal 3, we'll have the following number, which is used to connect one batch to another. But there is a problem with this formula, because actually you can use a trick to create the same number from different equity, different debt, and a different base price. Actually, if you set the base price, the value of the token higher than 2 to the power 64, it allows you to create the same number also for a different equity and a different debt. And that's the issue which allows us to bypass the system. And let me explain you why. Okay, but before this, the problem with this is that, if we set the price of the token to a very high value, to higher than 2 to the power 64, everyone will be able to see that one of the token is worth $1 million. This is a problem because everyone will know that the proof was faked, but there is a way to hide it. And let me tell you why. How? So actually, because there are many batches used to create the proof, we can only change the base price in one of the batch. And how we do it? We do it by lowering the number of the total debt or total equity by 1. And when we do it, then in the next batch, we can increase the price of the token by 2 to power 64, and it will give us the same number like in the previous batch. And only in this one batch, the price of the token will be very high. One token will be worth millions, which allows us to fake the debt, to do anything when it comes to debt and the equity. And in another batch, we can restore the previous value, and no one will be able to detect that the value was changed and faked. Okay, and later, after finding this issue, I created a demonstration of this issue in our repository. We contacted Binance. We shared the bug, information about the bug and our reproduction test with them. We also proposed how to fix this bug. We created a pull request for the repository. And after some conversation with one of the developers, they agreed that the issue exists, and yes, this is a correct critical issue, and they accepted my fix for the solution. And the fix was to limit the price of the token to not be higher than 2 to the power 64. Okay, and what's important from this, later Binance, we released a press statement with a Binance, and they reshared our tweet. And this was quite successful tweet because we reached around 700,000 views, which makes it one of the most important tweets from us. Okay, and what's important from this story? The problem is that in this case, the bug was only in proof of reserves. You couldn't use this bug to hack someone, to steal the money. But the thing is, if this bug was found in a smart contract, probably it would allow to steal everything, because it basically allowed to create a fake proof which couldn't be detected that it is fake. So in case of smart contract, it would allow to steal everything, but fortunately it wasn't a smart contract. But anyway, the thing is, everyone makes a mistakes. You know, even the best one, like the Binance, made a mistake. It's very hard to avoid them. Right now, the systems are so complex that it's almost impossible. So it's always a good thing to have another third party, an auditor, to check your code you create. It always helps. And also during our technical assessment, we found a few other minor issues. And if you are interested in details, how exactly the bug works, because it's a little bit complicated in the presentation, feel free to check our final audit of the Binance Proof of Reserves. Thank you.
check. Hi, everyone. Hope everyone had a great lunch and is having a great time at ETHDubai. My name is Nico. I'm the founder and CEO of Tenderize, and the presentation just went away. Oh, it was just on the screensaver. Okay, let's go. So I'm going to give a little bit of a technical talk today. I actually prepared this because I thought there was going to be a hackathon, and I was informed the hackathon was yesterday and before the event. But nonetheless, let's still have the talk, and we'll talk about building scalable protocols with clones. Like I said, my name is Nico from Tenderize, founder and CEO. Before Tenderize, I worked for LivePeer for 3 years, building their smart contracts and protocol. So this will not be a deep dive into proxies. If you want to learn more about proxy contracts, I suggest you go to the DEF CON archive and check out Alice in Proxyland from Alejandro. It's a really great talk on proxies. And the credit for the ID that we're talking about today, it's not my invention. The credit for it goes to Zephram from SudoSwap and Wigawak from Hard@Deploy. So why do we use proxies in smart contract development? 2 reasons: upgradability and creating multiple instances of the same code. If we drop upgradability and we just want multiple instances, we basically get clones of the same contract. And why do we need clones at Tenderize? Why do we need multiple instances of the same contract? We're a liquid staking protocol, and what we do is basically build a ERC20 token and vault for every validator on the network. So it's the same piece of code deployed over and over again. For example, in the case of the Graph network, there's like 300 indexers. So that would mean we would have to deploy the vault and the token 300 times, which is not really that cost efficient. You can also think of something like Uniswap, whereby each liquidity pool is the same piece of code, just with different tokens and parameters that it handles. So let's see how this actually would work without a proxy first. And we're just going to set an immutable variable A on a contract. So this talk will have a bit of code in it. I was told this was not a good idea, so I hope it's like readable. So if we just have a regular contract, my contract, and we want to set an immutable variable, we just do it in the constructor when we deploy the contract. And the variable A will then be filled in the runtime bytecode of the contract. Now, if we want to switch to a proxy, this becomes really problematic. You can't use a constant or an immutable with the proxy. So variable A will be saved in storage instead. And because we're using a proxy, we also have to match the storage between the bottom contract and the top contract. Otherwise, you can get storage collisions, which could lead to very bad things happening to your contract. So here the top one is the implementation, and the bottom one is the contract, and users would call the bottom one to execute the logic of the top one, but the storage would be written to the one below. But if we now want to access the parameter A, and this can be, for example, the token that we use in a liquidity pool, or for our case, the validator that a specific vault will stake to, then this becomes a very expensive storage read each time we want to access this. So as to summarize, with a proxy, you have no immutables. You use storage operations, which are very expensive. And you need to make sure that the storage layout of your proxy contract matches the implementation. And that has led to many exploits already over the course of the last few years, not matching the storage layout correctly. So how does this happen if we use clones with what we call immutables? You basically have a contract, and it has a function to get the value of A, but you see there is no declaration for an immutable variable, variable. There is no declaration for a storage slot for A. Yet, if we call get A, we will be returned the value that it's supposed to be. And if you see in the middle right about, it actually loads something from the call data. How does this work? So when we deploy a clone, we will actually deploy it with some arguments attached to it. Here you can see in the first green part that we create our arguments. In this case, we want to set the value of A to 1337. And we then deploy the clone with those arguments. And if we then call get A on our contract, we will get the value returned. But like we said, it was never initially declared here in the contract. So what kind of sorcery is this, and how does this actually work? So let me explain a little bit of the magic to you. This is, on the left, you see basically the library of clones that was written by Zefram and Wigawag. And the essence of what it does is the first part of the bytes memory immutables, the arguments that we supply, they're actually appended to the bytecode of the proxy contract you're creating or the clone you are creating. And then with every call you make to your implementation, what you have added to the bytecode at the end is appended to the call data of the function you call. So you can access this piece of call data with the arguments from your implementation contract. And what it achieves is basically you get the same characteristics of using immutables or constants, but then with proxy contracts. The only downside is that the amount of arguments you can append to the bytecode is limited in length, and the entire length of the appended bytecode would be added to the call data, but luckily call data is pretty cheap, so it's not really that big of a problem. And as a practical example, how do we use it in Tenderize? We have 4 different parameters that we want to get cheaply, and that is the asset that is being staked, the validator being staked to, and then 2 internal modules that we use. And none of these functions actually use storage slots, so it makes it really cost efficient for each instance of the contract to fetch the parameters it needs. And it solves a big problem of otherwise having to use initialize functions in your proxy contracts or your clones, which is not really nice for UX. And if you don't do that correctly, can also lead to severe exploits. So I'm keeping it short today, so thank you for listening to this technical talk. Thanks for Zefram and Wigawag for coming up with this. If you want to know more about Tenderize, you can visit our website, or we have a booth all the way in the back to the right. Feel free to hop by. We still have a few t-shirts and shorts left, not many, but yeah, you're welcome to pick them up. Thank you, everyone.
इधर से सामने से हाँ एक दे So okay, how many of them? 1, 2, 3, 4, 5, 6, 6. Yeah, you can talk to the others.
can start in 2 minutes.
2 minutes?
I want to start on time because it's 2 p.m., right?
All right.
According to this, 1 minute. According to this, it's written here. 14 o'clock. You guys start at 2. So it's if you can message everyone, like everyone.
Yeah, got it.
Yeah, no worries.
Maybe if you could like put it like this, it would be great.
All right, let's begin. All right, welcome everyone to today's panel about enhancing the capital efficiency of liquid staking. I'm Diogo. I work for Davos XYZ, over collateralized stable asset. And today I have the pleasure to have a very insane panel of speakers. I would say that we should start with a small, brief introduction because we're short on time. Let's start with Nico.
Yeah, sure. My name is Nico, founder and CEO of Tenderize. We do liquid staking for various protocols. Before doing Tenderize, I worked at LivePeer for nearly 3 years as a protocol engineer.
Hi, my name is Philip. I'm a chief of DeFi at Anchor. Anchor is a Web3 infrastructure provider offering liquid staking, RPC nodes, app chains, and other things. My background is actually more on finance, so I used to be a wealth manager for 8 years, mostly in Swiss banks before going full-time into DeFi and working at Anchor.
Does this work? It's off.
Hey, can you hear me?
Yep.
Awesome. Yep. My name is Ariel from SSV. Great to be here. I got into crypto in 2017, working for Bancor, where we developed the first automated market maker. And for the last couple of years, I've been leading the product at SSV Network, where we're developing distributed validator tech as an underlying infrastructure for staking applications on Ethereum.
Hello, everyone. Sorry, that was a little bit loud. Is that better?
Yeah, it's better.
Okay, thanks. Yeah, so my name is Jorge. I am a blockchain and cryptography researcher at the research team at Nethermind. I am also a business co-manager at the research team. I have been working on blockchain for the past 2 years, and before that, I come from an academic background. I'm currently a PhD candidate in applied mathematics at the University of Michigan. And yeah, but currently I'm mostly looking at blockchain and crypto, and it's been great so far. Very happy to be here with you guys.
Hi everyone, Andre Cronje, originally one of the co-founders of Phantom, eventually became one of the board of directors of Phantom Foundation. After that, launched a few DeFi dApps, Yearn Finance, Keeper Finance, stuff like that. Nowadays, just focusing on base layer scaling. So nice to meet everyone.
Great. So the first question that I have for you, and let's just like, if you guys want to talk about a specific question, you just grab the mic like a tool, and we can proceed. So the first question is, what are some of the challenges associated with liquid staking, and how can they be addressed to enhance the capital efficiency of the process?
All right, I'll go. So, counter argument, I think liquid staking is overly capital efficient in that I think it should never have been invented. And I think it removes the something at stake problem, which is the whole principle of proof of stake. And I think it over leverages the same assets by allowing you to, let's take ETH for example. I deposit my ETH. That ETH is supposed to provide network security, but now I get SETH, whatever, it doesn't matter. Now I take that SETH and I go deposit that in Aave, and now I go borrow DAI against it. So now I've just double dipped on the thing I'm supposed to provide security on. So I am actually actively subtracting security from the ecosystem because this asset is overly capital efficient.
Yeah, I would definitely agree with that take in that saying that liquid staking fundamentally changes the incentive structure and the security that liquid staking is supposed to bring. However, despite that fact, we have currently protocols on the market that are able to, are making it work or are finding alternatives to the original incentives structure. So we can think, for example, of the case of Rocket Pool, in which they go for every node operator requiring to have 16 ETH as collateral in order to start up a node. And this approach can be seen as less capital efficient in the sense that if I want to start up a new validator with Rocket Pool, I need to have that capital available. We have the case of Lido, which relies on like whitelisting and reputation of the relevant operators and parties. So this challenge on how like capital efficient the resulting liquid staking protocol will be depends a lot on how you want to solve that problem that Andrew just pointed out. Okay, so we just, in a way, we just broke or we just modified the financial incentives of liquid staking for node operators to behave correctly. So you need to fix that. You need to add something else. Some additional incentive, whether it is a bond of your own or reputation of your own that you're putting at stake in order for the, to guarantee that the node operators will behave correctly. And whatever design choice you make at this stage is going to determine the capital efficiency of your resulting solution. And there's a whole conversation that can be had on what's the best way to proceed. But yeah, that would be my point regarding this challenge.
Yeah, so in my perspective, I think it's very important to have that kind of reference rate. And when you have like DeFi composability and reusing liquid staking, I think that really helps the whole ecosystem to be a bit more capital efficient, because let's be honest, right? In DeFi, to attract users is mostly about attracting rewards and so on. And, you know, DEXs is one example, for example, to have liquidity. And, you know, when you use, for example, ETH, let's say on Phantom, on Polygon, or elsewhere, like you don't really have a real utility for ETH itself, and it doesn't have a reference interest rate, and you could just create maybe a liquidity pool against ETH liquid staking, especially if you're not even on Ethereum network and on another network. The benefit in terms of capital efficiency for the DEX, it will be now it's earning, you know, like half of the liquidity pool is earning 4% in ETH liquid staking APY, for example. And that makes also the DEX spending less rewards to attract additional liquidity. So if you do not use the full benefits of DeFi composability, it's as if the reference rate is kind of starting at zero. And then you need to, basically, every protocol needs to attract liquidity and users starting from zero. But if you consider, then the layer 1 or the layer 2 is having a reference interest rate that is lower risk than your protocol itself, which is probably going to be the case if you have a DEX on top of Ethereum network, Polygon, or Phantom, then it is actually a must that you offer a higher APY, right, than the underlying chain that is lower risk. So I think it's really important, and the main challenge, it will be how to make it liquid enough, right, so that you can make that DeFi composability more important and easier. I think the benefit for the chain itself is also quite significant because if most people stake, right, it's more likely that it's going to happen if the liquidity risk is lower. And if the liquidity risk is lower, the staking ratio of the token of the underlying chain is going to be higher. And at some point, you will see, you know, back in the days like Solana, they had about 78% of all the tokens staked, for example. So what happens when you don't actually have enough tokens freely available to fuel all the liquidity in DeFi? That's obviously a big problem. Where look at, for example, STETH on Curve, for example, there is like 1.6 billion and half are in Ethereum. They're just not doing nothing in there, those Ethereum. It's not very capital efficient, obviously. So yeah, I think it's really, to summarize, really important for the ecosystem because of that reference rate analogy.
Yeah, I want to support what Andre said, that saying liquid staking are highly efficient, but the problem is that they're so efficient that we have a problem of stake centralization, meaning that we have one big entity managing a big percentage of the stakes, right? We have Lido with, I think, about 80% of the liquid staking market. And this is problematic because they also have a very centralized infrastructure, right? Lido has a few dozens of operators managing all of the stakes. So I think in order for us to mitigate these problems is to adopt more things that can help distribute that stake and reduce the risks in centralized operations, as things like DVT that we're developing in SSV, which can really help to have more operator participation in the networks, meaning we'll have Ethereum security in way more hands and having it more decentralized for all of us.
Yeah, I think there's been some interesting viewpoints here. I think liquid staking doesn't necessarily subtract from the decentralization. I think it could add to it if it's done in the right way. When we talk about capital efficiency in staking or liquid staking, it's kind of twofold. One is that if you are a validator business today, a lot of your cash flows are actually not liquid. So it's very hard to scale up a validator business and build a more secure network together with better validators. The other part, if you look at the liquid staking landscape today, is, as mentioned, Lido controls a big part of that market share. It's like, I don't know, 35 validators for 30% of all stake deeds, something like that, which is obviously not a good thing. And if we look at the other solutions that are available, there are slight differences in the approach, but in essence, they are all picking like a small subset of validators that are available on the network. They're essentially all just yield aggregators, and the landscape of liquidity, but also who you stake to, is highly fragmented. What we are missing for liquid staking at the moment is a base layer underneath that, liquid staking natively to these protocols. But that's kind of hard to build if your protocol is already live. So what our approach is at Tenderize is we are trying to create that base layer underneath, a liquid staked vault and token separate per validator, where you don't share or socialize rewards and losses. That's kind of our viewpoint, and that could lead to a more consolidated liquid staking space, more options available, all with one protocol that is decentralized at the full core and is fully neutral and doesn't make decisions on, hey, we should stake to these 30 validators and leave the other 1,000 out of the boat. I think we should create a level playing field for everyone, and that's where we should start to increase capital efficiency.
Okay, great. Moving on to the next question. So how do staking providers ensure that they are providing an efficient and cost-effective service for liquid staking? And what kind of strategies can they use to improve their offerings?
Yeah, I can take that one. So I think what is happening right now for liquid staking providers is to attract users and basically stakers. They obviously dilute very heavily the token of the liquid staking protocol, so the governance token. And currently it's kind of the easiest way to attract users. If you want to be more capital efficient about it, you obviously need to think about the use cases, right? So you can obviously try to list your liquid staking token on a lending platform like Aave. You can obviously, you need to have the DEX liquidity pools for sure, because the main advantage is to offer liquidity immediately, right? When compared to unstaking, which typically takes a few days, and it will also take a few days after the Shanghai upgrade for Ethereum. I think that part is really important. You can also use it in other protocols that are a little bit more for advanced DeFi users that want to trade on yields, like Pendle Finance, for example. So I think that's really important, is really to have a collaborative approach. If you're kind of a growth marketing manager for liquid staking protocol, is really work with other DeFi protocols, have other use cases on top, helping the other platforms to be more capital efficient, because if they can create a liquidity pool for their own token, let's say SushiSwap. Imagine Sushi does a liquidity pool with like STETH. Well, obviously, they will benefit now from the ETH liquid staking rewards, and why doing it with Sushi ETH liquidity pool when you can do Sushi STETH, for example. So that will make them also spend less rewards for their own liquidity pools. And yeah, I think really to have the collaborative approach is important to be more capital efficient. Otherwise, you will just dilute indefinitely the value of your liquid staking protocol. And if you go on DeFi Llama, you will see that there is already like 60 liquid staking providers So obviously there is that kind of winner-takes-all approach. And I think really the partnerships with other big protocols that might want to use maybe another liquid staking provider instead of Lido can actually help to reduce also the dependency on that kind of winner-takes-all approach from Lido.
Yeah, I think it's a, to what Philip said, it's a big issue, right? Having liquidity and having a market for the LSDs is very important, even after Shanghai will come out, even though the risk will go down. But how do you incentivize that liquidity, right? So project right now, we see they're spending millions of dollars every day to incentivize that liquidity, which really makes it hard for new projects to come in and start competing in this market. So as Philip said, we need to have more adoption, more utility for those LP tokens within DeFi and our ecosystem, so it will further incentivize the liquidity provision for those markets.
Yeah, liquidity providers are one part of the service providers or liquidity protocols. For us at Tenderize, it's something that we built inside of the protocol. So for us, when we look at service providers, it's more the validators that are backing liquid staking protocols. If you look at it today for them, for the validators, it's a funnel to attract more stake, but what you don't see is validators putting their own money into liquid staking protocols, because in many of these, let's take Lido as an example, if you as a validator want to put your own money in, it gets split with the other validators in the pool, and you lose any competitive advantage that you have. So for us, for service providers to become a bigger part of liquid staking is for them to be also included in becoming users of it and not just acting as a service provider and a funnel for them to attract more stake. We want, for example, for validators to also be able to enjoy the benefits of liquid staking, like collateralization or, I don't know, other structured products like maybe delta neutral staking.
All right, moving on to the last question, because we were a bit short on time. And this is actually quite a popular question that has been going around a lot. So how does the availability of liquid staking impact the potential price movement of Ethereum in the light of the upcoming Shanghai update? And how might this affect the incentives for staking?
Yep. So I think it's incredibly important to understand that liquid staking was created originally to provide liquidity to staked ETH, because that was not redeemable. You could not unstake Ethereum, right? So obviously it's a very important event, the Shanghai upgrade, because you will be able to unstake Ethereum. So that also changes a lot, the benefits of liquid staking. And actually that's why Anchor, moved into other liquid staking or other chains quite early. Why? Because we understood that it was much more capital efficient if you have a liquid staking that is redeemable, meaning that the circulating supply of that liquid staking token is elastic, right? So that's a much more efficient price stability mechanism than just incentivizing indefinitely liquidity pools for a liquid staking token that is not redeemable. So obviously, Lido did a great job for that. But they will also benefit from this by having to incentivize much less rewards. So, yeah.
Yeah, I won't talk about the ETH price, but what the Shanghai upgrade is very important for is being able to rebalance the liquidity pools. So what happened like a couple months ago was that staked ETH was trading at a fairly big discount compared to ETH. Well, if you can't unstake and redeem that ETH, you can't add it back into the liquidity pool and rebalance that. So the Shanghai upgrade is actually very important for creating a healthier and more efficient market for liquid staking on ETH. I think without the Shanghai upgrade, calling it liquid staking is a bit of a misnomer perhaps, because that redeemability is actually critical to the process of liquid staking.
Right. So I think we're set and done, just right on time. Hope you guys enjoyed the talk, and thank you guys so much. Okay, we can end off the That's my new LinkedIn profile picture.
You're next? Yeah, it's yours. Sorry.
Hello. Hi, everyone. Thank you for showing up at the talk. Really happy to have everybody here. Just do a short intro. Nina here from the Arbitrum Asia team. I mainly lead the growth in Arbitrum for the APAC region. It's such a pleasure to be here to talk about a little bit about how we grew to the ecosystem to where we are today. So, has everybody here heard of Arbitrum before? If you thank you, thank you. Glad that we have made our name out there. So what is Arbitrum? Why are we doing what we're doing? We started this project back in 2015. Back then was a university project, completely academic, for Bitcoin scaling. So back then Ethereum wasn't a thing yet. There's no such thing called Ethereum. But then we're already considering about, okay, when Bitcoin gets big, how are we going to scale it? So originally, this was a Bitcoin scaling project. So after a few years of development, Ethereum came along, and there's something called smart contract, and the congestion in Ethereum became big. Vitalik wrote an article called a Rollup-centric Ethereum roadmap. And that's when we pivoted the project, first from academic to commercial, but also from Bitcoin to Ethereum. And then it became what we know as Arbitrum today. We are a leading Ethereum layer 2 protocols. We use a technology called optimistic rollup, and we provide ultra-fast transaction. It's usually 10 to 50 times cheaper transaction with a security driven directly from Ethereum layer 1. So here's a bit of roadmap or milestone we had in the past years. We originally had our mainnet launch in August 2021, and last year in August 2022, we had our Nitro upgrade. So that was the roadmap of how we evolved. We also have a different product called Arbitrum Nova mainnet. So currently, Arbitrum is known as, everybody knows it as Arbitrum, but little people know that we actually have 2 different chains for different use case, which I will dive into a bit later. So how big is Arbitrum right now? Anybody here have interact with protocols on Arbitrum? Raise your hand if you have used Arbitrum before. Okay, what did you use? What protocol did you use on Arbitrum? GMX? Wow, that's a big one. Yeah, we actually have some friends from GMX here today, so they will be happy to hear that. So Arbitrum is actually right now the second largest DeFi ecosystem, just after Ethereum Layer 1. In the past few months, we flipped Polygon, we flipped BNB. We have 3.6 billion USD locked in our ecosystem. We are currently 50% of our market share. We have over 1,000 dApps across from DeFi to SocialFi to gaming to infra. They're all deployed on Arbitrum. And we already have 3.3 million unique wallet addresses in this ecosystem. So amazing growth over the past year and a half. But everything happened organically. We never paid any developers to build on our ecosystem. Everybody was believing in us and voluntarily building their projects on Arbitrum. And all the users are voluntarily putting their money in this ecosystem. So you must be wondering, like, why, right? How do I get such growth in my ecosystem? Why would people like Arbitrum so much? So here's a bit of why we think we came to where we are today. So first, we're very security focused. We are a rollup-centric chain, completely aligned with the rollup-centric Ethereum roadmap written by Vitalik. And this rollup is an essential step of Ethereum development and is widely recognized by the Ethereum community. So we completely believe in this vision, and that's why we design our protocol in a way that's completely in compliance of the rollup vision of the Ethereum community. So just a little comparison between what's difference between Arbitrum 1 and sidechains. We have a full data availabilities. All the call data are posted on Ethereum Layer 1. So that also means the Ethereum Layer 1 validators are actually in charge of the security of our protocols. We utilize something called fraud proof. So when the malicious behavior takes place, security is guaranteed by Ethereum Layer 1. And what that means is, compared to a sidechain is still vulnerable when it comes to when 2/3 of their independent validators are corrupted. But for us, we can withstand 99% of attacks on validators. So that was the difference on the security level. And because we're so focused on security, DeFi protocols are willing to put their money to bring their users to this ecosystem. Because at the end of the day, the worst thing a chain could happen was it got hacked. So every protocol, all the developers want to protect the user, and thus they want to choose a chain that's security focused. And we're also very ETH focused. We're very lucky that we're able to work with major staking protocols such as Lido to bring staked wrapped ETH into Arbitrum ecosystem. We really believe in the future of Ethereum. So we actually have 870K ETH in Arbitrum right now. And that's more than the ETH, accumulated ETH, than 10 other chains combined. That includes Polygon, that includes Optimism, that includes Avalanche. So that just shows how much the Ethereum communities have faith in our ecosystem, that they're willing to put their hard-earned money, hard-earned ETH, long-term assets into our ecosystem. And we also have a multi-chain future. As I mentioned, Arbitrum currently have 2 different products. The first one is called Arbitrum 1. This is a very DeFi-centric project. This is a traditional rollup, and when I say traditional rollup, it means all the call data got posted to Ethereum Layer 1. It's very secure. It's usually 10 to 50 times cheaper than Layer 1. And the main use case would be DeFi and NFT. However, it also has a drawback, right? Not all solutions is perfect for all scenarios. DeFi is very security-centric because a lot of money is involved. But in other use cases, such as gaming and SocialFi, there might not be so much asset, but people need very cheap transactions and very frequent transactions as well. So that's why we develop a new chain called Arbitrum Nova. Arbitrum Nova is usually 30 times to 150 times cheaper than Ethereum Layer 1. And because it's so cheap, it's ideal for use cases such as gaming or SocialFi or Metaverse. And we actually co-launched it with Reddit. If you have ever used Reddit, you know there's something called karma in this ecosystem. And Reddit is actually issuing their karma points as a token on Arbitrum Nova. So this is an ecosystem that has a very different gene compared to Arbitrum 1. So if you are developing something that's social related, that you want a lot of people to involve on chain, Arbitrum Nova would be the choice. So we have two very different products for different use case because we understand that not one single technical solution will not be perfect for all use case. So we have different technical solutions for different use case in our roadmap. Another thing I want to talk about is user experience. So when we first launched Arbitrum, there's a lot of controversies around if Arbitrum is going to be big or if optimistic rollup is going to be big. And one of the major arguments is that optimistic rollup has something called 7-day withdrawal period, which means if you want to take your money from Arbitrum back to Ethereum layer 1, it takes 7 days. But right now, if you use Arbitrum, you realize you never have to encounter that because we think on behalf of our users. We think on behalf of the user experience that we bring in a lot of partners that can help users to smoothly translate in and out of Arbitrum. So on the centralized exchange side, you can use Binance, Coinbase, Kraken, or any of the centralized exchanges listed here to easily put your money into Arbitrum or withdraw it from Arbitrum. If you don't like centralized exchange for obvious reasons, you can also use decentralized bridge protocols. We have Hop, Connect, Seller. They're all very easy to use. You get your money within 1 split second. So that's also another choice. We also have a lot of fiat on-ramp partners. So if you're in Dubai, if you're in India, you can always use your own currency and easily buy it into USDT or ETH on Arbitrum. So we provide a lot of ways, we lower the barrier for users to enter our ecosystem, and that's why people are so easily putting their money into our ecosystem and play with all the projects we have, with GMX, with DOPAX, with TreasureDAO, and that's what we want to see when everybody has a chance to experience what we can bring with our technology. And last thing is also the most exciting thing I want to talk about today. It's EVM compatibility. It's a start, not the end. So with a lot of talks on Rollup, I think right now everybody wants to be EVM compatible because from a developer point of view, obviously being EVM compatible is easy, right? You can use your favorite tools. You can easily migrate your projects from Ethereum layer 1 to Rollup, and that has a lot of benefit. But now it seems like it's only the start, not the end. So what that means is that we are releasing something called Stylus, and we're bringing a new concept called EVM+. So in the future, with Stylus, we're actually going to support Rust, C, and C++ as the tools to build on Arbitrum. And major advantage is that with all these new languages, developers can take advantage of the benefit of this language. For example, a program written in Rust is actually an order of magnitude more efficient than the program written in Solidity. And this language exists in Web 2 for so many years. There's way more developers knows how to write in C and C++ than Solidity. So our founder has a very good saying that if you want to bring in next billion users, we have to bring in next million developers. And this is a major step that we take to bring in more Web 2 users to use the tools they are familiar with to build more efficient and faster and cheaper decentralized apps in Arbitrum. And it also allows developers to do something called customized precompilers. Precompilers is a special smart contract that can efficiently do some very specific tasks, such as computing hashes. So this is particularly interesting for Ethereum researchers because they will have the chance to iterate on, for example, a EIP precompilers without setting up their own testnet. So we are very excited to be part of this Ethereum revolution with all the Ethereum researchers, providing with them best tool and environment to do their research. So at the end of the day, Arbitrum, we are here to serve all the developers. We always put developer experience as part of our priority. And thus, in the next upgrade, we're going to have something called Stylus that will provide even more broad language support in the ecosystem. And this is a bit more about Arbitrum, docs, what happens in the ecosystem. And I'm happy to take any questions at the end of the presentation. Yeah, please. Sorry, I couldn't hear you quite. So I think what I heard was my opinion about ZK and optimistic rollup. So this is obviously a major discussion in crypto Twitter right now. I want to say that Arbitrum, we're never taking sides in terms of the technology, right? We have never said that optimistic rollup will be forever better than ZK rollup. We're not fighting against each other. What we said is that today, ZK rollup is not ready for the market. As you can see, there's no market-ready ZK rollup that can be used by developer today to launch a project or to sustain a mass over 1,000 decentralized apps to build on it right now. That being said, our chief scientist at Felton has never stopped researching on ZK rollup. So if when the technology ZK rollup is ready one day and will be happily adopting it in different ways. It could be part of our existing chain, could be a new chain we're rolling out. So there's a lot of things we can play with both rollups together. So we're never really shutting the door to the ZK rollup. Thank you. Please. So we actually, so just to repeat the question for everyone, the first question is, do we have a timeline for decentralizing the sequencer? The second question is my understanding is there any plans to offer not first come, first serve, but for different strategy for sequencer? So I don't have a specific timeline off the top of my head, nothing I can share right now, but this is obviously a priority of our team. There are partners that we are talking closely with to run our validators, and then I think in the first we will be whitelist, and then it will probably open up to the public. And to answer your second question, we actually published a new article about a month ago stating that we have a new update on the sequencer. It's not going to be first come, first serve completely, but it's going to be within 0.25 seconds, you will be able to bid on who comes first. So this will encourage projects to not spend resource on hardware resources to get into the queue first. Instead, if they really want to, they can have a controlled way to bid in front of 2 or 3 other transactions, but just within that very, very small window. You can't really front run somebody that's completely ahead of you, but just within the 2-3 transactions, you can actually become the first. Yeah. Thank you. That was a great question. Alrighty, thank you everybody for taking the time to learn more about Arbitrum. Definitely check out our website, our ecosystem. A lot of things are happening in the ecosystem right now. And yeah, enjoy Arbitrum and Layer 2.
I don't know. Yeah, that's. 소개하고 비디오 틀고 하려고 했어요. 이어서 비디오. 그러면 화면은
Good afternoon, everyone. My name is Dongju Lee. I'm a CTO of LightScale. Today, I'm going to introduce Wemix Canvas that we are building to solve the blockchain scalability problem. It is a Rollup-based Ethereum layer 2 platform. So let me start with a short introduction video about Wemix Canvas. Okay, these are topics that I prepared for this presentation. At first, I will simply talk about background. Then I will introduce our development strategy, and I will describe protocol details, including decentralization strategy. Finally, I will present current status of Wemix Canvas and future roadmap. I believe that all of you have thought of blockchain mass adoption. To make more people adopt blockchain, scalability problem should be solved. Ethereum network have reached its throughput limit. It's about just 1 million transactions per day. There have been much efforts to solve this problem, such as sharding, sidechain, plasma, and so on. Some of them can be grouped into layer 2. Layer 2 solves the blockchain dilemma by separating execution from consensus. Layer 2 lowers the fees and higher the throughputs while inheriting security guarantees of Ethereum. Finally, builders can expand their projects into new applications with improved user experience. There are different types of Layer 2 solutions, such as Plasma, State Channel, Validium, Rollups, and so on. We are not going to compromise security and decentralization to get more scalability. Therefore, Rollup is the only practical scalability solution for us. There are two main streams in Rollups, optimistic and GK. Optimistic Rollups are more widely used because they are EVM compatible, but they have the late finality. In opposite, GK Rollups have faster finality, but they are EVM compatible. And this makes it harder for dev developers to join the ecosystem. To solve this problem, several teams are building GK EVM, but it's not enough because it still takes too much time to generate proofs. According to L2Bit, total values locked in all layer 2s is more than $6 billion. As shown in this figure, TVL of optimistic rollups is about 90% of L2s. Although TVL of GK rollups is increasing, still optimistic rollups dominate the L2 market. From this, it is clear that keeping usability is very important for the success of rollups. These are key features that we defined for our system: security, decentralization, low fee, high throughput, EVM compatibility, fast response, and fast finality. We designed Wemix Canvas to include these features. Our philosophy plays an important role of determining many things like development strategy. Before talking about details of Wemix Canvas, I'd like to mention our philosophy. The first one is pragmatic. I think it's time to make it clear. So we mainly focus on making something that works properly for the real use cases. Adaptive. There are so many great contributions to the blockchain technology. We adopt them, make it better, and finally share it to the community again. User-friendly. We are always keeping in mind that we have to provide the best user experience. Following the philosophy, we adapt various best practices from existing projects such as Optimism, Arbitrum, Scroll, and so on. Optimism is one of the widely used optimistic rollups. Optimism team have operated Optimism network more than 2 years. Recently, they have been developing Optimism Bedrock. It has inspired our team so much. So we took many things from Optimism Bedrock: modular architecture, rollup and derivation processing, and P2P. These make it possible to bring lower fees, higher throughput, and faster response. Arbitrum's interactive fault proof is very efficient. We adapted it to our ZK fault proof mechanism. Scroll is contributing to the ZK EVM so much. In conjunction with Ethereum Foundation, we basically started with their ZK EVM. Therefore, we will have fast finality in Wemix Canvas and EVM equivalence. Based on those foundations, we added our original ideas to make Wemix Canvas. At first, we have tried to use GKP to rollups in a way that is practical. So we begin with an optimistic rollup where fault proof is implemented with GKVM. We call this kind of fault proof as GK fault proof. At this stage, GK proof is only used to resolve dispute challenges because we have not yet optimized GK proof generation sufficiently. After optimizing GK proof generation, we can move to EVM equivalent GK rollups. We designed a smooth transition mechanism from optimistic rollups to GK rollups. Decentralization is one of the important problems we have to address. We have been designing and implementing Wemix Canvas where validators and proposals can be easily decentralized. Okay, let's look into more details about Wemix Canvas. Network participants, rollup and derivation process, about how Wemix Canvas handles deposits, withdrawals, and transactions. There are two things that I'd like to introduce how GK proof is used in Wemix Canvas. The one is GK fault proof for optimistic rollup, and the other one is GK proof pipeline for GK rollup. There are three types of participants in the Wemix Canvas network: users, proposers, and validators. Users can deposit or withdraw transactions on L2 by sending data to a contract on Ethereum mainnet. Users can submit arbitrary transactions to proposers, just like the layer 1. Proposers accept users' off-chain transactions and observe on-chain transactions. Usually, on-chain transactions are deposit events. Proposers consolidate both kinds of transactions into L2 blocks with a specific ordering. Validators derive L2 chain by reading data in L1 chain. They also verify the integrity and also checkpoint. If there is any invalid assertions, validators can also submit dispute challenge on the invalid assertions. Regarding the network participants, there are some differences between Optimism and Wemix Canvas. First of all, I changed node names from sequencer to proposer and from verifier to validator. I think this matches well to the participants of layer 1. This makes it more natural to reuse layer 1 components in the similar way. In Optimism, sequencers not only submit batches, but also checkpoints. On the other hand, in Wemix Canvas, proposers just submit batches, and validators also checkpoints. By changing like this, validators can receive rewards from checkpoint assertions as well as dispute challenges. Consequently, I think this resolves verifier's dilemma. Let's see how L2 blocks are loaded up to L1 by a proposer. L2 blocks are built with L2 transactions from mempool. L2 blocks have reference to the L1 block so that deposit transactions in the L1 blocks will be properly included in the L2 blocks later. As shown in this figure, L1 deposits are stored in the first L2 block just after the L1 block. L2 blocks are more frequently created than L1. For now, L2 blocks are created at every 2 seconds, so several L2 blocks are encoded and compressed into a channel. Then the L2 channel is split into channel frames so that each frame can be stored in a single L1 transaction. A validator can read channel frames from L1 blocks as well as deposit events. Then the validator can reconstruct a channel from this data. And finally, L2 blocks can be built from the channel and deposit events read from L1. These processes are managed by multiple components. Just like the L1, the execution engine manages mempool, builds L2 blocks, manages states, and serves RPC requests from the user. The rollup node requests to build a block to the execution engine with proper payloads. The batcher manages channels and channel frames and submits channel frames to L1 network. The Rollup node in validator reads frames from L1 blocks and derives L2 blocks. The Rollup node uses engine APIs to build L2 blocks. There are some complicated issues that we have to consider when we implement Rollup and derivation processes, but I skip them in this presentation. Okay, let's see how Wemix Canvas handles deposits and L2 transactions with these components. At first, users submit deposit transactions to layer 1. Then the Rollup node watches deposit events and creates payload attributes with the deposit transactions. The Rollup node calls on engine API so that the execution engine creates a block with the payload. Users submit L2 transactions to the execution engine. Then the submitted transactions are included in blocks when the Rollup node calls engine APIs. The batcher gets the latest block cache from the Rollup node and then reads the block body from the execution engine. Then the batcher submits blocks to the batch inbox in L1. The Rollup node in a validator gets blocks from batch inbox and transforms them into L2 block inputs. Then the Rollup node requests to create blocks with the payload to the execution engine. The validator components get the latest checkpoint output from the Rollup node. The validator component submits the output to L2 output Oracle contract at every 1800 blocks. With 2 seconds block time, it is an hour. Output loot is generated with the version type and payload. Same version number means that the structure of a payload is the same. In the current version, payloads are made with state loot, withdrawal storage loot, and latest block caching. Output loot will be used for confirming withdrawal from L2 to L1. For a user to withdraw his assets from L2 to L1, he has to submit a withdrawal initiating transaction to L2 contract first. Then a proposer node posts batches with withdrawal transaction data to batch inbox. A validator gets the blocks and also an output that contains withdrawal commitment. The user needs to wait until the block is finalized. After block is finalized, then the user can request to finalize the withdrawal to the bridge contract. Bridge contract verifies the transaction with the output loot by checking if the withdrawal storage loot contains the withdrawal data. If the transaction data is verified, the user finally gets his asset. This figure shows the overall architecture of Wemix Canvas without dispute challenges. Currently, we are using modified Go Ethereum as the execution engine. Therefore, built-in peer-to-peer network and transaction pool is used to propagate transactions. The same network is used to propagate submitted blocks and support snapsync. Ethereum creates blocks at every 12 seconds, but Canvas creates at every 2 seconds. Therefore, there may be unsubmitted blocks in the proposal yet. Those unsubmitted blocks are called as unsafe blocks. They are propagated through another peer-to-peer network of Rollup nodes. Using those two peer-to-peer networks, execution engine can respond to user requests with low latency at every node. Until now, validators only act as an asserter. Now let's see how validators act as a challenger. Let's assume there is a faulty output that is provided by another validator. That is an asserter. At first, the Rollup node of this challenger gets block data and transforms the data into L2 block payloads. The Rollup node calls an engine API with the payloads. Then execution engine build block. This validator component reads an output from the L2 output oracle and also reads the corresponding local output from the execution engine. Then compares them. If the assertion output is different from the local output, the validator submits dispute challenge. To resolve the challenge, the validator first needs to find where the difference starts from at a single block level. After finding the block, the validator component requests to generate a GK proof to the GK prover. The GK prover gets execution trace for the block from the execution engine and generates a GK proof. The validated component submits the proof to the L1 contract. Then the GK verifier contract verifies the proof. If the proof is verified, the challenger wins and gets the rewards. If the proof cannot be verified, the challenger loses and his staked assets will be transferred to the asserter. Let's see more details about these two parts. When identifying a faulty output, we begin with the two checkpoint outputs. The first checkpoint output should be the same to the challenger's local output. Between those 1800 blocks, there must be an initial block where the challenger's output and the asserter's output are different. The challengers get to know the initial block position by interacting with the asserter, who submitted the faulty checkpoint output. At first, the challenger submits 46 output loops that evenly distributed between these blocks. Then the asserter compares these outputs to his local outputs and finds the first different output. Then the asserter submits all the outputs between those blocks. Again, the challenger compares those outputs to his local outputs and finds the only different block. Then the challenger generates a proof that shows his output is valid and submits the proof to the Colosseum contract finally. This figure shows the state transitions in the Colosseum contract. The challenger starts a challenge by staking his asset in a checkpoint. Right after staking his asset, the challenger submits output segments and an asserter should respond to within a time limit. In most states, there are some time limits so that the challenge processes ends within the reasonable time. In the previous example, the faulty block was found with just 2 interactions, but there may be more interactions with different segmentation schemes. Interactions must be an even number so that a challenger can start the interaction and submit the proof after the assert's turn. We tested several segmentation schemes. Among them, this 5, 9, 8, 9 segmentation scheme consumed the least gas. We inherit GK VM of Ethereum Foundation and Scroll. To reduce the proving time, we use a GK try instead of a Buckle Patricia try. We use Poseidon hash instead of Keka and GK try to compute the path to account or storage slot. We added additional specs for layer 2, such as L2 deposits and load of gas fee processing. This shows the circuit structure. There is a super circuit that embeds many circuits designed for the specific purposes. With these public inputs and this private input, we can obtain a block proof. Circuits are not fully implemented yet, but I hope it will be finished soon. Yeah, this is the previous architecture without challenging. Now we have the full architecture. Those are additional components to use zero-knowledge proof in optimistic rollups and GK rollups. Wemix Canvas have GK-friendly data structure and hashing schemes from the initial stage. Therefore, even though we start from the optimistic rollup, we can move to GK rollup without heavy migration process. At the GK rollup, validators act as provers. They also checkpoint outputs with a GK proof. Okay, let's see proving pipeline. Once a block is created, a prover will generate a proof for the block. While blocks are created at every 2 seconds, generating a proof usually takes much more time. So multiple provers need to generate proofs in parallel at the same time. In this figure, except the first proof, Others include previous proof in their proofs. Then the checkpoint can be verified using only one proof. Created proofs will be propagated among provers through the peer-to-peer networks of Rollup nodes. If we submit the checkpoint with a large interval, large public input should be addressed to verify the proof. If we submit the checkpoint with a small interval, the cost to submit checkpoints will get higher. Therefore, when we move to GK rollups, we need to determine the proper checkpoint interval considering these trade-offs. If we reduce the probing time sufficiently, we can move to GK rollup. There must be a coordinator for the transition. In this figure from the block BI plus K, a checkpoint output is verified with a proof. After the challenge period, the network can be considered as a GK rollup without any further changes. There must be more issues that we have to address. This is the basic idea how we can transit from the optimistic rollup to the GK rollup. There are two types of decentralization in Wemix Canvas: validator decentralization and proposer decentralization. At the first phase, we are focusing on validator decentralization. I mentioned before, validators can get rewards by asserting checkpoint as well as challenging invalid checkpoints. This will motivate node operators to join Wemix Canvas as validators. We are finding proper parameters for the stakes and rewards for now. We are going to use trusted execution environment when we adopt proposer builder separation. I think this is simple, but can support strong censorship resistance and blocks MEV abusing. Currently, we are researching in conjunction with external research teams for this issue. I hope we will have practical implementation for this in the near future. There are many challenges that we have to address. The first one is GKP optimization, which is what we are focusing the most at this moment. We are using Poseidon and GK-Try. These make execution engine work slowly. So optimizing execution engine is another important issue we have to solve. We need to modify our components according to the proto-denk sharding. And I already mentioned the PBS just before. We will support account abstraction in Wemix Canvas as soon as possible. This is our roadmap. We have finished the POC, and now we are preparing to open our public testnet within a month. At this time, there will be a single proposer and multiple validators operated by private members. GKVM will work, but not cover all the specs yet. We will support full peer-to-peer propagation, which means you can have fast response time at every node. I hope that we have an EVM equivalent GK rollup in the next year. Yeah, you can visit this site to see our teaser, and you can check our source codes in this GitHub soon. And we are going to provide full resources when we open our first testnet. Thank you for your attention. Do you have any questions? Yes? I'm sorry? You mean the testnet timeline? Mainnet. Yeah, we are planning the third quarter of this year, but it starts as an optimistic rollup.
You want to see the video again? In full screen or in this screen?
I'm sorry? Actually, we are not have any plan to issue tokens for this layer 2. And so, thank you. Have any question?
You need to put it in full. You need to change the display. Yeah. You can play the video.
Good afternoon. Ooh, this is a loud microphone. I will not yell in this because I'm gonna make everyone deaf. But it is cold in here. Raise your hand if it's cold. Oh, I got 1, 2, 3, 4. Everyone in the room. All right, cool. So today's subject is gonna be a very good one. It's gonna be about investment. And we have a great person here to talk about that, which is Kavita Gupta. So let me introduce myself first. So my name is Romain Caillé. I'm with Evervision. We build on Arweave. We're a Web3 infrastructure provider, but we don't care about that today. We're going to talk about investment. So before we start, let's introduce Kavita a little bit. So she's the founder of Delta Blockchain Fund, an early blockchain infra fund with over 120 million. She has over 18 years of experience. If you have the World Bank, IFC, Eric Schmidt family, office, et cetera, et cetera. She started one of the first blockchain early stage funds, Consensus Ventures, invested in first checks and sensors, defining companies like Polygon, Starkware, SoRare, and I think there's a whole bunch. So welcome.
For having me.
Perfect. So let's start off.
Did you notice that the audio system is very interesting here, spatially? I think we need some distance.
We need. Okay,
No,
let me take a little righty here. Okay, so let's dive right into it. So investments. To you, what is the difference between investing in a startup today to investing in a startup like last year or 2 years ago? What is the biggest thing for you?
I think the market is very different. We saw the last bull cycle in 21, and so I would say last year and a year before. Right till Luna crashed, the market was really, really bull. So we were looking at investing where the market was overpriced. There was a lot of token sales happening, raising a lot of money, so the retail was good. But then we suddenly saw incredible founders having two types of dilemmas. First, people who raised at high valuation but didn't really close their round, or closed their round thinking that they're only going to raise for an year or two, are in a position where their valuations have already been set up high, but nobody's ready to invest anymore at those numbers. And they don't want to do a down round, but the extension round is creating trouble for them. The second issue which we are facing is the valuations have gone down by 70 to 80% for the new projects. So just an year back in this space, even if you have an idea and you just felt like, I have this idea, I have an incredible background, I'm a first or second time entrepreneur, you can go into the market and raise at $30 million valuation or so. And we have reached a point where even a $10 to $12 million valuation for exactly the same pitch deck is lucky to have.
So that's an interesting comment. And to that I say, do you think we have better quality projects now than a year ago? Or do you think they're, I guess, the same quality? I say this because I recently went to ETH Denver, and the amount of devs that were talking about actual protocols and actual tech was insane, right? To compare to the year before, where it's really more about money than anything. So I want to know your take on that.
So I think the fascinating part is the builders, for the first time since the whole last 3 cycles of bear market, this is the first time there are still huge amount of builders who are continuously building. So that's great as a VC because you're still getting amazing amount of deal flow. But the quality, it's not like suddenly really good projects have come into the space because it's a bear market. There's nothing like that. What has happened is a lot of fluff has disappeared. And, but a lot of new builders are still building. So somehow deal flow is consistent with respect to number, but the valuations have gone down significantly.
Okay, so this leads on to another question I have about that. Okay, so you say the quality doesn't really, I guess, hasn't really gone down. For you, what do you look for today? You know, I guess last year it was easier for you to make investments. Today, what is something that really, you know, gets you going about a project?
I think in the bull cycle, we see a lot of applications. We see, like last summer was all about DeFi, right? We call it a DeFi summer. And during that DeFi summer, we saw a lot of money going into a lot of experimental DeFi. And then we saw a big boom of NFTs. And when we saw a big boom of NFTs, we started seeing a lot of experiments there. The one thing which we consistently has been not paying attention to, and I think something you will relate to because as your project is also on a big infrastructure platform, is infrastructure is still missing for the whole blockchain stack. We are focusing in a bull market a lot of application layer because they are sexy and they're like easy to sell and easy to get adoption on. What we forget is decentralized identity, databases, cross-chain analytics, reportings, monitoring tools, security, like all those different stacks are absolutely not there. So I'm very excited with the bear market to focus a lot on those. So I feel like there are three big sectors right now. One is MEV. So suddenly you have over 40, 50 MEV projects coming into the space. Second is optimization of rollups and even L2. So you have a lot of zero gas execution layers which are coming into the space. And then the third one is decentralized staking. And I think decentralized staking emerging into DeFi staking, these three are going to be big three infrastructure hooks which are going to completely change the ecosystem.
So in the middle, you said NFTs, right? So obviously everyone here knows that NFTs were a very, very big thing. What's your future? What's your take on the future of NFTs?
It's a twofold, I would say, an idea to look at. If NFT is going to continue to be used as a quick in, quick out JPEG platform, then there are traders for that who, instead of using DeFi trading, are doing NFT trading. But if we actually going to see NFT as an asset class, as a collateral class, there's a lot of infrastructure projects on NFT-Fi which are coming out. And I think those NFT-Fi projects are going to create the next layer value of NFTs. The second part of NFTs, which could be super interesting, is how are you going to create hardware ecosystem, whether this is for NFT display, whether this is for, if I'm buying a $2 million NFT like Beeple's NFT, and if it's a collectible, how are you going to display it and have the genuineness to have a social acceptance behavior or a social show-off behavior to have that, knowing that somebody can just right-click it, copy-paste it, and have it at their home too, but yours is different. I think once we have solved those two problems or those two particular sectors and develop them, I see NFT coming back in a big way.
Yeah, yeah, NFTs, I guess, you know, when it derailed with all the 10,000s and everything, it kind of ruined the whole NFT experience for me, at least, right? NFT was exactly what you were saying. Now, just in parentheses, if anyone does have a question here, you definitely can ask. I will come up to you and we'll ask her a question. That's just in case. Now, back to a more investment type question. So obviously we talked about before and after. How about in the future? How will this bear market change investments for the future?
I think it's a very interesting time to be a founder and to be a VC. If I look at pragmatically, yes, valuations are low, but it also takes away the pressure of actually delivering in 3 months or 6 months or 9 months. You have a lot of talent available for cheaper prices than the bull market. You have a lot of patience to deliver your tokens, actually spend time in research if you're doing tokens. If you're building an equity company, then really on the idea of the first customer. If I would be a founder, which I've been in the past, I enjoy bearish market to start a company, because if you start with the 10, 12, 15, $20 million valuation, you're only going to go up. You're not thinking about down round. You're either going to completely disappear or you're going to go up. You also then have a 1 year, 1.5 year to really slowly build, hire the best talent. Every company you think could be your potential partner or customer don't have craziness of money, so they are available to talk to you. So people are more humble, people are more available, talent is more available, money is tight, but it's good, smart, sustainable money.
And you know what, that's actually a good point. How many devs here, or how many founders are in here? Not many, oh, maybe there's one. So maybe for her, like how would one approach a VC, right? The right way, what would they need to do in order for you to want to listen or to like pique your interest? What are things like that?
So I want to take away one big taboo for founders, which I also had back in 2013 when I started my company. The shyness or thinking that I am the one who need a VC. Actually, that's not true. The VC equally and morely actually wants a good founder. So that's just one personal thing which I've realized a lot of time when founders come. There is a sort of uneasiness that the founder is seeking VC. VCs are equally seeking good founders. So the good equation is whomsoever you like if I would start a company, I would first make a list of 30 to 40 VCs whom I strategically think are good for my company. And then I have a backup 20 to 30 list, because at the end of the day, I also need to survive. If I already know people, having a hot connection to VC always helps, because a lot of VCs talk to each other. A lot of our founders send us deals. So if any of my portfolio company founder is sending me a deal, definitely the first call has to happen with the new founder. If any of our co-investing VCs send us, we 100% go through the deck. Otherwise, wherever you find them, in conferences, in the networking events, I get 2 of my best deals in my life, I actually got through Twitter messages. And you will be very, very surprised. And now the company is defunct, but I got into BlockFi at $5 million valuation, and I got out at $5 billion valuation. And I got that deck on Twitter, on my personal messages. So VCs also, we may not come back that fast when we get LinkedIn or Twitter messages, but if we have a deck, it definitely goes through our team to go through it. And if we have an interest, we will find that founder wherever we have to find.
That's good to know. So yeah, just take your chances, message everyone on anything, Instagram, Twitter, whatever, you just do it. But that's, so we talked about how devs or how founders can kind of get your attention, but why would a founder want to choose you? What does a founder need to look at in a VC in order for them to choose that particular VC?
Very, very good question. So at least I'll first speak for Delta, and then I'm very happy to talk about generally, if I would be choosing VC, what are the things to look at? Or let me do the other way. So whatever sector you are making, today the blockchain space is big enough to have sector-specific funds, because that gives you a lot of credibility in their partnerships. So for an example, if I'm building a DeFi protocol, who's going to provide me security audits? Who's going to provide me product market fit, who's going to provide me liquidity for this DEX, who's going to give me partnership with the top companies with whom I want to set, whether it's layer 2 solutions, layer 1 solutions, with chains at the senior level to launch the product. So there are like a lot of different things. Even when we talk to founders, we sometimes ask them, why do you want us to lead your round or us to be part of your round? Because we want to see if they have done their homework or not by that point, especially after talking to us once or twice. For Delta, I started my investment journey. I'm a solo GP for Delta. Before this, I started Consensus Ventures, Tachyon. I also teach at Stanford Beyond Bitcoin class. I got into the space in 2013. I was fortunate enough to be first check in companies like Starkware, Polygon, Quantstamp, Sorare, OpenSea, Coinbase through funds, FTX, etc. So we know most of the top founders directly. They are friends, they are investor in the funds, they are advisor to the fund. So we provide smart contract auditing priorities at discounted rates. We provide deep tech diligence. We connect you with any L1 and L2s you want in the space. We connect you with the best product market fit from Web2 spaces, institutional custodies, getting your account on Coinbase or anywhere within a week. So those are just some type of direct help which our team works with. But we also help you think through your round and introduce you to some of the most credible VCs, because most of them have started literally in front of us and with us. So.
That's a perfect explanation. I really enjoyed that one. So in terms of VCs, and this is a personal question actually, can you invest in anywhere basically, or is there like, since you live in America, are you not allowed to invest in certain countries, et cetera, et cetera? That's a personal question of mine.
We invest globally, and in, of course, today's regulatory environment, so far, like until and unless somebody is registering their company on a very random island, which our lawyers have like no idea what's going to happen if they just disappear, we don't. But it's very standard and very normal to know someone registering in BVI or Bahamas or Singapore, Dubai. Like there are a bunch of jurisdictions which are common jurisdiction if you are doing or thinking about doing a token. And if it's an equity company, I think there are, again, preferred jurisdictions. So far we haven't come across that problem. I'm sure there are some islands which are banned, but we have not seen that so far. The thing which we think through regulatory is if there is a token, there's a token warrant, and we invest in pre-seed and seed. So by that time, founders have not really thought through how that token design is going to work. We do add an extra point saying that if we are leading the round or significant exposure to the tokens, our legal team has to approve the usage of that token as per the SEC rule. Otherwise, we cannot hold tokens.
Got you. So are you also wary of that type of stuff, like where the companies are based or not?
I mean, founders are very smart, most of the founders, and we usually ask them, okay, for an example, recently we closed with a company who are registered out of Germany, and that's not a very tax efficient place to register a company, first of all, even for equity. And then they wanted to do token warrants, which is very gray area in Germany. So we asked them straightforward. We said, where are you planning to do your token foundation? And are you going to move your company to Lisbon at a certain point, because that seemed like a thing. They did, so we put a clause that if they moved, it has to be exactly the same structure. Because in 2016-17 craziness, a lot of people raised money on the same company 3 times at 3 different jurisdictions.
What? That's crazy. Okay, so I got into the crypto space around like, yeah, 2017, but I was a day trader, so I didn't really go through that type of stuff. I had a great one here. I lost my train of thought. Wait, give me one little second. I had it at the tip of the tongue. Oh yeah. Okay. So you talked about right now. You just talked about using 3 different companies and whatnot. That doesn't happen anymore today, obviously. Do founders try to actually find ways to still do that, or not? I mean, I'm kind of curious now that you were talking about it.
It's a human behavior, right? So you have, you can have weird VCs and you can have weird founders, right? So there has been a lot of fraud which has happened in various different bull cycles in the past. There has been a lot of very interesting frauds, and this is not even the worst fraud which I'm telling you. I mean, there has been token sales and the website has disappeared and have a 404 error in 2 days after a public sale. But those were the early days and you just learn from it. And also VCs now know what other regulatory or legal diligence to do on the founders.
Yeah, of course. That's obviously it's the due diligence is very important. And now, final question: what are your what is your favorite area to invest in right now? What do you think is the thing that kind of gets you, or what's the sexiest thing for you right now? That's the final question.
My personal solution, which I have been actually trying to find a really good product from a very long time. There are 1 or 2 people who are building somewhere around it, but they are at the very early stage, so I haven't seen the product. Is a decentralized identity from the core of infrastructure, starting from your data storage to the application as an individual vertical. What I've seen, what we do have right now are very fractured identity. So you have social identity like Lens protocol, you have payment identity like ENS for your wallets or Spruce or other things, but you really don't have an identity on ZK or in a way with privacy, which if I walk into a hotel and instead of giving my identity card or my passport, which has a lot more information than what a hotel booking guy needs, I just give them a verified government identity, which is also connected to whatever the payment system I want to do, and use it back on chain for any settlement too. And I think going back to the infrastructure, until and unless we don't have those basic tenets, but without which none of the identity worked, right? There is no civilization which started without a name of a person, giving an identity, but we now have a whole Web3 world without an identity. So that will always remain the most sexiest topic for me.
My mic broke, I guess. But that's exactly, I agree with that. It makes it, I guess, more fun, right? In order, like, you actually have an identity, and this is why the NFTs kind of also had, at least for me, kind of like having your own little identity within an NFT. I think that was pretty fun. But hey, thank you so much for this talk. I had a blasty blast. Hope everyone enjoyed, and catch you soon. If you have any questions, maybe your founder, you can definitely find her. And would you like to give any, maybe your Twitter, Telegram, Instagram, so they can DM you?
No, Telegram is the best because that's so easy and fast today. My Telegram ID is KAVZG. And if you don't find me here, just find me here and I'll just give you my QR code. But thank you so much, guys, for having me.
Thank you. Have a good one.
Hello, everyone. My name is Togul Maharamov. Today I'm going to be talking about rollups through the prism of validating bridges, or in other words, how rollups actually work. So to start, let's discuss what rollups actually are. So rollups, and just to note the data availability mode of the protocol, that's it. Everything else is an implementational detail. So this illustration shows how it works. So a chain B posts the data to chain A, and this data should be enough to reconstruct the state of chain B. And that chain can be classified as a rollup. So what is data availability? Data availability is a mode that defines, for some predefined amount of time, let's say T, the protocol data is made available to all the nodes that are willing to download it. And so you shouldn't confuse it with protocol data storage, because data storage is a problem of making data infinitely available. So rollups inherit data availability guarantees of the underlying layer. That's what rollups are. And as a side effect, rollups also inherit ordering guarantees of the underlying layer because of the data being posted, and I'll explain what ordering is. So ordering is a phenomenon that defines a sequence X once it's finalized, and that sequence can no longer be changed or updated later once the finality is reached. So as you can see in this figure here, there's a block in tip that is comprised of a sequence of transactions. And because it's a tip, it's not finalized yet. It depends on the protocol, but let's assume that in this particular protocol, the tip is not finalized. And at some point, there's a fork that completely reorgs the contents of that block. So it still contains the same transactions, but they are reversed in their order or whatever. At that point, there's no way of telling which fork is going to be the winning one, which fork is going to be included in the canonical chain. But once the chain A and the block in the chain A that contains a sequence, so in this case, it's the former sequence, is finalized, you can consider the block to be, the contents to be finalized, so the order can no longer be changed. And basically, that allows us to have data ordering for free just by posting data on the underlying layer. So now to rollup types. There are two rollup types that are necessary to be known. Sovereign rollups and classic rollups. Note that when I refer to classic rollups, that's what you know as rollups. It's your conventional rollups deployed on top of Ethereum, etc. So the difference between a sovereign and a classic rollup is that the goal of a sovereign rollup is to inherit some security from the underlying layer. So let's say Ethereum or Celestia or something like that, you want to bootstrap the security from them instead of deploying the chain from scratch, and you deploy a sovereign rollup. And then classic rollups scale and introduce new features to the underlying layer through a trust minimized bridge. Sovereign rollups permit the participants of the protocol to define the fork choice rule. What I mean by fork choice rule is this. So as you can see in this case, there are 3 different forks that the users can choose. And while in a classic rollup, the fork choice rule is defined by the underlying layer, so a rollup, the chain to which the rollup posts the data chooses the fork for the users. In case of a sovereign rollup, it's actually done by the users or by the protocol, by the consensus. And that's why we call them sovereign rollups, because the users decide which fork to follow. So in other words, the canonical chain is defined by the protocol participants. Meanwhile, the ordering within the canonical chain is defined by the underlying layer. So you can think of it this way. If a certain order has been finalized, the users are free to choose any transactions within that order and define them as the part of the canonical chain. So with that out of the way, let's look into classic rollups. Classic rollups on top of inheriting data availability. And ordering guarantees also inherit censorship resistance and validity guarantees from the underlying layer. Note that validity guarantees are inherited based on certain assumptions that are made by the state transition enforcement mechanism used by the rollups. I'll go into that later. That's a lot of big words. So censorship resistance is defined as some time u within which a user-originated transaction is guaranteed to be inserted in the canonical chain. Note that the actual definition is a bit more complex, but I don't want to go into the details here because I'll just bore you for hours. And validity is execution, is enforcement of execution that is compliant with the state transition function of the protocol. So what I mean by it is every protocol, so let's say Ethereum has certain rules that the protocol has to follow, and validity enforces that those rules are followed. This is an example of a state transition function. I know it doesn't really make any sense. It's just a bunch of weird-looking symbols. But if you look at it in this way, it's actually a state transition function of Ethereum from Ethereum's yellow paper. So sigma prime is the new state. The weird-looking Y that is called epsilon is the state transition function. Sigma is the previous state, and the transaction is T. So what it means is that a state transition function, Y, epsilon, takes the previous state and the transaction and outputs the new state that is produced after the execution of the transaction. So essentially, you can define a state transition function as a set of rules that the execution needs to comply with in order to successfully mutate the state of the system. And by mutate, I mean modify the state of the system, whatever that is. So for Bitcoin, it's the set of unspent transaction outputs. For Ethereum, it's the state of all the accounts in the system that are non-empty, etc. And back to validity. Validity guarantees are either enforced through fraud proofs or zero-knowledge proofs. There are two enforcement mechanisms for that. Fraud proofs optimistically enforce the validity of a rollup by allocating a predefined time V for the onlookers to challenge the committed state. What I mean by it is, let me show you in a graph. So if you look at the figure here, there's an executor. It's the entity in optimistic rollups that commits the state to the validating bridge. And I'll go into what a validating bridge is later. And there's another entity, and that entity is permissionless. It can be anyone in the system. So they follow the committed state and then fetch the state from the bridge and compare it to the state that they locally computed. So let's say if the states are not equivalent for some reason, they can initiate a challenge. And once the challenge is initiated, that they basically go back and forth between the challenger and the executor until one of them is proven to be correct, or the original state commitment or the claim by the challenger. And there is another model that is called, what I described now is called an interactive multi-round proof, but there's also a fraud-proof mechanism called non-interactive single round, in which the challenger just submits the witness for the correct state, and then the contract just verifies it without arbitrating the back and forth between the two entities. And now zero-knowledge proofs. Zero-knowledge proofs enforce validity of the rollup by proving the correctness of the computation via cryptographic system. So in case of a zero-knowledge proof, the rollup looks a bit different. So the sequencer posts the data as well as the state to the validating bridge, and then the prover just commits the validity proof that proves that the state was computed correctly. There's no other interaction needed whatsoever. So there are two types of classic rollups, optimistic and pessimistic. No, I'm joking. Optimistic and zero knowledge. Note that some people refer to zero knowledge rollups as validity rollups. I'm looking at Starkware people. So the difference, optimistic rollups utilize fraud proofs to enforce validity, And zero-knowledge rollups utilize zero-knowledge proofs to enforce validity, as the name might suggest. So classic rollups, that's what makes classic rollups unique, is they get their trust minimized composability with the underlying layer for free as a side effect of validity guarantees. So what I mean by trust minimized composability is composability. So composability is basically when you can connect between two systems, and trust minimized composability is when that communication between two distinct systems is trust minimized. And by trust minimized, I mean a system in which the assumptions required to securely communicate is 1 out of n, where n is unbounded or weaker. And luckily, both fraud proofs and zero-knowledge proofs comply with the definition of trust minimized, so both of them allow you to have trust minimized bridging. So finally, after 11 minutes, I come to the topic in the title, validating bridges. Validating bridges inherit the security guarantees that are, the security guarantees are enforced by validating bridges. Just to remind, the 4 security guarantees of a classic rollup is data availability, ordering, validity, and censorship resistance. And validating bridges enforce validity either through the use of fraud proofs or zero-knowledge proofs, as I previously explained. And this is an example of how the validity proof or validating bridge works. So you see a rollup, and it posts data, and at some point a zero-knowledge proof or a fraud proof if the data is incorrect to the validating bridge. And then the chain is the chain that it posted to guarantees certain security properties that I described before. And as you can see here, if you remove the validating bridge, there's no longer those guarantees. So the guarantees are inherited through the validating bridge. If you remove it, you just get a sovereign rollup. So, and from this, we can deduce that the validating bridge is what defines a classic rollup. Note that it is possible to have a validating contract that doesn't actually bridge, but there's no much use case for it, and also it doesn't really matter from the purpose of the premise. In that case, the classic rollup would be defined through the validating contract, or whatever you want to call it. And finally, how bridging works in classic rollups. So this is what you expect from a classic bridge, just a normal bridge. A user, let's call the user Alice, sends a request to the chain to deposit 5 ETH to a rollup. The chain records that request, and then somebody picks up that request. It depends on a bridge design. There are multiple ways you can pick up that request and put it to the rollup side bridge, and the rollup bridge just sends the 5 ETH to Alice's account on that side. And the same is in reverse, so Alice requests the bridge on the rollup side to withdraw 5 ETH back to the native chain. It just somebody, through some arbitrary mechanism, you pick up that request, relay it to the other chain unlocks the funds and sends it to Alice. But it's not how rollups work. In rollups, you have this additional mechanism, which is very important. So originally it goes the same way. So Alice requests a deposit, you mint 5 ETH by relaying it to the bridge of the rollup, whatever. But at that point, the transfer actually didn't happen. The transfer happens once the correctness of that transfer is proved to the native chain. And once that's done, then you have a transfer happening, which means that unless the proof mechanism that the rollup uses is broken, it's impossible for somebody to mint the tokens that Alice didn't originally request. And the same goes the other way around. So Alice requests the withdrawal is relayed to the validating bridge on the chain, And for the withdrawal to actually be processed, you need to prove that the balance had sufficient funds and all the state transitions up to that point were correct. And so just a short conclusion. So rollups can either be sovereign or have trust minimized composability with the underlying base layer. They can't have both. Those two are basically mutually exclusive. And finally, if a rollup has trust minimized compatibility with the underlying layer, then by definition, the rollup is defined through the validating bridge. So if you remove the validating bridge, you no longer have a composable rollup. Thank you. If you have any questions, feel free to ask.
So left is on. So whenever we get notified.
Hello, everyone. Can you hear us okay? Sorry, probably to be one of the last of the talks or panels. And that too, ZK, at the end of the day, is going to be quite a challenge. So thank you all for coming here. So today we have William, Igor, and how do you pronounce the name?
Togrel.
Togrel, okay? So, yeah, that's me, Anish, okay? So sorry. So I'm suggesting this, like, why don't we introduce yourself? William, why don't you start? Give you 30 seconds, introduce who you are, what you do, then Ego, and then you, and then I will do last.
All right, hi everybody, I'm Will. I work at Polygon Zero. I work on all kinds of ZK stuff, like Plunky2, Starkey, which are like some of the fastest proving systems out there.
Hi guys, my name is Igor. I'm not sure I can fit in 30 seconds, but I like to work on stuff earlier than like everyone else. I built the kind of the first EVM to EVM bridge back in days, working on stable coins since 2018 on XDAI, which was acquired by Gnosis. Now I'm very interested in making stablecoins more decentralized, especially with the focus on recent events. So I'm building ZK Bob, which is a stablecoin with optional privacy layer, and it's utilizing ZK technology to make stablecoins more accessible. Yeah, happy to be here.
Hello, everyone. My name is Toril Maharamov. I do research at Scroll. Scroll is a ZKVM-based layer 2 that is being built on top of Ethereum. We're specifically type 2 ZKVM, which means that we're EVM compatible. I mostly work on protocol research and incentives and how to design the bridge and stuff like that.
So I guess my turn. So compared to them, I'm a bit older. So I've been around a lot. I mean, early advisor to Ripple 2013, a part of the Ethereum Swamp team, been doing ZK, the non-interactive version since 2016. So these days I have my own protocol called Panther Protocol, for which I'm a co-founder, CTO, and the chief scientist. So kind of, you know, talk no nonsense and try to do the nonsense. So let's get to the thing. So the question here is like, this is what I was hoping to do. So I have a bunch of questions that we agree, and we'll go through that. Everybody gets a chance to air their opinion. And then when we are done, I'm hoping that the audience will have questions. And if you have questions, I don't know what mechanism will work. Maybe you could put your hand up and we will give you one of the microphones or something like that, okay? So, you know, let me get started for this then. So, if you have been in ZK, like I have been for a very long while, there's been a lot of investment. We could almost say that's almost the golden age of ZK. And at the same time, there's almost this other thing that's been happening. It's the surge against privacy, right? So I would love what each of the panelists have to say about this. I know different people have different views. Why don't you start, the opposite side?
I think let's start with like how ZK progressed. Like 10 years ago, the maximum what you could do is prove some do a range proof or something like that, something really simple, and even that was very expensive.
Yeah, I mean 2013, technically speaking, we had Pinocchio, so we could prove something.
But in terms of like functional protocols, it wasn't really a thing. And now we Polygon guys are proving the computation of an actual EVM in minutes and hopefully in the foreseeable future seconds. So the progress that we've made in the last 10 years is tremendous. And I like to bring up zero-knowledge proofs as an example of how cryptocurrencies contributed to the real world, because without cryptocurrencies, I don't think zero-knowledge proofs would have been nowhere near the state-of-the-art. Zero-knowledge proofs would have been nowhere near what they are now.
Agree.
Well, I'm looking from product perspective, right? So what makes me think that we're somewhere near a golden age is that it's kind of easy to take crypto primitives and use them as building blocks. So definitely we see more use cases unlocked during last 2-3 years, right? Basically, DeFi team can take a ZK primitive and build a ZK-enabled solution, right? So far, we see it like for computations. Definitely, ZK VM is a big one, right? But I think we will see a lot of other VMs, right? Application specifics, but also for not only for general computations, but also for applications themselves, right? For example, we're building a stablecoin, but ZK is an important part, right? Because it unlocks new possibilities for the stablecoin, right?
I would even go further. I think even Web 2 has a lot of possibility for ZK.
Yeah, that's right. And that's a good point that cryptocurrency, like crypto market, enabled a lot of research in ZK. I think crypto did a lot to Rust, right? And second, did a lot of to ZK technology as well.
I was under the impression you had a lot to say about privacy too.
So yeah, I definitely think we live in the golden age of ZK, especially in the research and theory side. So like right now we have a ton of different ZK proving systems out there, and you can kind of pick and choose which part you want. So like you can get a different IOP, which is like kind of the information theoretic part of the ZK protocol. You have a bunch of them, and then you have the cryptographic part, which we call the polynomial commitment schemes, and then we have tons of those, and you can kind of pick which zero-knowledge proof system you want depending on like your constraints. And that's something that wasn't possible a few years ago. Like the standard was Growth 16 for a while, and now it's totally deprecated in some sense. So yeah, I'm really excited about like all the future application.
Or do you want to still have your few words about privacy because you're really very keen to?
Are we allowed to talk about privacy? Well, sure we're allowed.
Yeah.
To talk, yeah. I mean, that's...
Larger contracts of ZK and privacy. So it's like ZK could be used for lots of things. Privacy is one of them.
Yeah.
And your thoughts, you clearly think privacy is important. So, how do you describe it to an audience who's new to ZK, new to privacy? Why is it important?
Well, yeah, it can be a long monologue about privacy and implications of current regulation and so on. So first of all, I think that in the modern financial system, there is a lot of privacy already built into existing protocols. I think it's normal for decentralized protocols to embed privacy as primitives as well, right? I think what was missing before, that like if we build payment protocols on top of decentralized cryptocurrencies, we should combine several blocks, right? So first of all, like most of payments built using stablecoins, right? We should have some decentralized stablecoins and so on, right? We should have decentralized and resilient infrastructure, like layer ones, like Ethereum, sometimes something less expensive, like Rollups and so on, right? So third building block should be, which is enabling a lot of transfer applications is some form of compliance, right? Decentralized compliance where ZK primitives can be embedded as well, right? Polygon ID and some other protocols are working on it. And for sure, the privacy itself for transactions is important. So when we think about payment solutions for decentralized network, we should have like all components. And after that, we can say like, okay, this is kind of similar to existing solutions in Web2 world, right? And but when we have only one part, let's say when we have only privacy, that can be considered as a element which should be regulated
Yeah,
with
interesting
like blunt
challenge.
force, right? What do you think?
I think at some point we will need some form of compliance because I don't think we're getting mass adoption without some form of compliance. But for now, I just don't think ZK is ready for the mass market, for like mass usage. So I think for now, the best use for ZK, and you can also see that from real world applications, is to scale blockchains, protocols, etc. And at some point, we're gonna get there, and we can use ZKs for privacy in a scalable manner where people can actually transact.
I want to argue, because I work in this space for like 10 years or so, and I remember during that time we had some ideas which were quite interesting and exciting, but very few people worked on them. Let's say decentralized marketplaces, right? So regulators had like cracked down on decentralized marketplaces, and we don't have this type of businesses on chain, right? So that's one big thing, right? Another one is like security tokens. At some point, if you remember, like in late 2017, projects started to kind of think about security tokens, and regulators cracked down on it, and now we don't have ETFs on chain, but we could have them, right? If like more people work on that and just say like, okay, guys.
Yeah, I mean, I would probably step in and say the obvious, because it's like all of us are builders.
Yeah.
Some of us build protocols. Some of us have protocols that have privacy implications. The challenge for us is to be within the framework that will allow us to exist. This, innovation happens mostly at the edges, and sometimes the society doesn't recognize the value of innovation. So, just to give an example, when cars were invented, apparently in the UK, you had to have somebody run ahead of it to warn everybody the car is coming, right? So that's how it was, pretty much illegal. So that is how things adopt, and how things get adopted, regulation happens. So it's normally a lagging thing, yes, and it's a big challenge. I completely agree. So shall we all agree to disagree that privacy is a key thing, and possibly we will see it happen in different ways and go to the next thing? The question here is like, William, I'm going to ask you to take this one. So if somebody were to say that the holy grail of ZK is ZKVM, would you agree or would you disagree? I'm sorry to put you in a hard position.
I would definitely disagree. I think ZKVMs are kind of the first step towards general purpose computations in ZK. And since Ethereum is so influential in the blockchain space, it was kind of the goal for so long. But now, like a lot of teams, especially Polygon, are ready to launch a ZKVM, a fully functioning ZKVM. So now that that is done, we can look towards the future. Like, what else can we build in ZK? What other complex systems can we build? Some other teams are working on ZK-ifying other instruction sets. I'm thinking about RISC-0, who's doing like a ZK version of RISC-V instruction sets. And I think we're going to see a lot more of these applications that are going to be built upon what we've done with ZK EVMs.
Go for it.
Yeah, I agree that custom VMs are important, and what we see right now with bridges, like ZK bridges, it's basically it's a form of virtual machine, right, where
state transfer mechanism.
Yes, state transfer it's quite complex operation, right? I think that's one of the next important application. It's interoperability between chains. Do you agree?
Yeah, I completely agree, and we currently have it already. Rollups are basically chains that are interoperable with other chains, and so you essentially use ZK to interoperate with other chains. But going forward, I think we're going to get more stuff that doesn't have to do with EVM and more general purpose applications, so bridges, privacy, etc., etc. So we're going to expand on non-ZKVM stuff. But for now, I would say ZKVM is the holy grail, but it's not going to remain like that forever. It's definitely going to, we're definitely going to have some more interesting applications for ZK.
So keep the microphone. I'm going to give you the next one. So in an imaginary world where you have the TEE, Trusted Execution Environment folks, say they are the way forward, and pretty much, no, you have to answer no. So what would your answer be if somebody from a project which uses TEs comes up to you and ZK is not the thing, we are the thing? What would be your answer be? Not one single sentence, a single word no, but you need to give a reasoning and a no, if that's a no.
I call trusted execution environments trust me bro execution environments, because that's essentially what they are. You just trust that Intel or AMD that they implemented the enclave correctly, etc. But as our experience in the past has shown, TEs are not something that we can rely on. There have been multiple exploits. There was another exploit recently with the secret network, and basically a bunch of researchers in 2 different ways managed to de-anonymize the entire network. And while I think that it was a good stopgap solution because using non-TE-based computation, privacy computation wasn't really efficient, we're getting to the point where I think TEs are going to start being deprecated relatively soon. You can still use them for other things. So for example, there's a proposal to use a multi-prover for zero-knowledge rollups, so using SGX as a backup solution for
No, it's fine, okay. Apologies. So kind of using an MPC to have a proof computation distributed across?
So essentially, you would compile the execution environment in SGX, and SGX would basically attest to the fact that they got the same state as the zero-knowledge proof.
Yeah.
And if both of them agree, you proceed. If one of them disagrees, then you stop the protocol and do something else. That use case, I think, is valid, because the worst-case scenario, you get the validity, the zero-knowledge proof security. So there's nothing to lose here.
Ego.
So what
can have an opinion?
Yeah, it's about hardware, right? Yeah, I think that
execution environment. That's the question, not
just
hardware.
I know, but can I talk about hardware acceleration, because that's more.
You have to say.
Yeah, no, I mean that I just thought about what are things that are stopping us from adoption on mobile phones, and really what we're missing is having hardware acceleration in
Absolutely.
modern chips.
That was supposed to be my next question. Okay. It was his turn to answer that and the next one.
That's a form of MAV.
Maybe attack on us. Well, if you have anything to say about TE, if not the question of hardware acceleration, do you think we are at a place where Bob just bypassed us like he did an MBB attack on us, okay? So do we think we are somewhere where hardware acceleration is going to be the thing that changes the ecosystem? Say, for example, in the late 90s, early 2000s, we didn't have SSL because SSL was very heavy. You had to flip END, and the servers had the bigger one. You had hardware accelerator to do the same thing. Are we at a place where we have ZK accelerators that do the same? That would be the question.
Okay. Do I still have to answer about TEs?
What did you say?
Do I still have to answer about TEs?
It's up to you. It's like, if you want to say something, you're most welcome to.
Okay, I have nothing else to say. They suck. We shouldn't use them. Yeah. End of line. Okay. About hardware acceleration, I think we're making a ton of progress. We have a lot of teams working hard to make ZK proofs faster and faster. And that's great, especially for ZK rollups, which will need a beefy prover for a while. I do think we need to focus on making provers faster also for consumer hardware, especially for privacy applications, because if you want to keep privacy, you have to prove on your own device. Or another option is to develop some kind of MPC protocols to have a decentralized prover, you split your data into a bunch of parts and then you send them to a different bunch of provers, but I'm not sure that's totally ready for production yet. So until then, we need to make sure that zero-knowledge protocols stay pretty fast in consumer hardware.
You did MEV, but you still have to answer now.
But you basically answered that what I want to answer. Yeah, I would like to confirm that for privacy applications, it's important to run on consumer devices, right? Because otherwise, it's very hard to decentralize computations, right? We have a good progress on modern devices, like proofs are calculated like 10 seconds on modern iPhone, so which is fine for in browser, right? In mobile app, it can be even faster, but it will be great if we can have it accelerated on hardware and upgradable for new proving systems, right? Just
Absolutely.
like
Okay.
new iPhone, new proving system, right?
Should I add something?
Feel free. Make it short, though. We don't have that many minutes.
I think if you're talking about hardware acceleration on consumer-grade hardware, so something that is accessible, then it's definitely a way to go forward because we can speed up things.
We had 386 and 387, the math cores. So we have GPUs, right?
Yeah, but like I'm not a big fan of custom hardware for like a specific, so like ASICs and stuff for proving because it's a centralization vector. So unless the ASIC that is custom built for a specific application is readily available, then basically you have to stand in a line for a year to purchase that.
So let's get on to the more interesting and more, I would say, religious warfare. Stocks versus snarks. Where do you stand? You have your microphone stuck with you.
I mean, the lines become more and more blurred every day. So when Starks were created, no Snarks had were transparent. They all used some form of trusted setup. But now we have Snarks with that are transparent. So certain researchers don't want to call them Starks. They still call them transparent Snarks. But I think the lines are getting more and more blurred as we go forward.
Agree. Igor, what's your religion?
For us, snarks are more suitable because we have to put proofs on chain, right? And the computational parameters of public blockchains are important. I think, like from the standpoint of quantum resistance in the future, we should definitely look into.
Quantum resistance is going to be for everything. All the ECC is going to be shit. So is all integer factorization. So we are not going to be alone.
Yeah. I mean, it's good to mention that the problem still exists somewhere, right? And with advancing AGI, it can be faster than we can imagine, right? We don't know, banks are failing every day, what's happening. Maybe it's quantum entanglement between the US and Swiss, who knows. I mean that, for now, for privacy applications on public EVM chains, snarks are more suitable, so that's where we stand right now.
Whatever you want to say?
Yeah, I totally agree with Tagul. Like the line is becoming very blurry. At Polygon Zero, we've developed a proving system called Plonky2, which uses the best of both worlds, right? So it's based on Plonk, which is traditionally a snark, but it uses some part of Starks to make it faster. And so it's neither a Stark nor a snark. It's the best of both worlds. So I think we're just going to see more of that in the future. And yeah, if you really want to get controversial, I think a better question is trusted setup versus no trusted setup. Yeah.
So we have probably 30 seconds each for last concluding thoughts, if you have any. So we almost reached time, so after you. What do you want to say now? Whatever you want to say that we didn't get a chance to say until now, go for it. Think as well.
I'm going to think about it.
If you don't have anything, we will give the audience a chance to ask us questions.
Well, I think it's a good time to ask for some questions, right? Because we throw some ideas.
Yeah. Anybody having questions?
Guys, do you have any questions?
We will give you a microphone, or you shout at me. I'll repeat the question.
I see a lot of friends in the here. Okay, friends, ask some questions. Oleg.
That is going to be a challenge.
Don't be shy.
Okay.
Anton,
Shall I give you the microphone? Here you go.
Anton, you can take one.
Thank you. Anton, go ahead.
Yeah, more general one. What kind of products do you think will come up first and will be powered by ZKP?
Sorry, did you hear the question? Okay.
What products do you think will come first based on zero-knowledge proofs?
What products will be coming first using ZK? Yeah.
Are we going into the who has the first ZKVM debate again? Because I'm already tired of having that one. So we already have products. I guess the question is the product that is popular and used on a mass scale. Then again, I guess the answer is ZKVM.
Okay, everybody can have a go. Nothing is stopping.
Well, I think end of March, we're waiting for ZKVM. I think the
first.
the year. Well, I think that the team will put a lot of marketing resources and will try to move a lot of projects into the technology, which will make interesting the consequences, right? Because like a lot of projects will migrate there without actually evaluating risks. So it will be good to see if its technology is resilient enough.
Okay, Will,
As
you
a
want to say
Polygon
something?
team, what do you think?
Yeah, I don't have anything to add.
Okay, good. One more question.
Since you're pushing for it, so privacy is obviously something that the regulators are not liking a lot, right? Transactions, you know, KYC, and all these other things. So, I mean, in your opinion, ZK would it actually find its way to like the mass market, you know, to the execution, or it's going to be all this constant cat and mouse game in between the developers and application, and then the regulator is trying to catch up, or the vice versa?
Okay, I'll give it the first shot just to make sure that it's really understood in the right way. So technology always has this challenge of sometimes in the gray area. Uber, for example, is a gray area. So yes, zero knowledge could be used to provide KYC and KYT. At the same time, you could also do shielded pools. So it's a question of like, how do you actually have the right balance? You know, is the regulator okay with the right kind of risk? Is the risk in line with what we actually have in the normal Web 2 world? It's the kind of question. Guys, go for it.
I guess the solution is to just, I think the problem that we had, for example, with Tornado Cash, that it wasn't just big enough for to fail. It was small, so the regulators can just kill it. Whereas if so, the way Uber worked essentially succeeded. It just became too big to fail, so the regulators just stopped trying to.
I might agree to disagree with you, but go ahead.
Okay, and I think there will be applications that are like compliant, so KYC, etc., AML, but like I am a bigger fan of the applications that are built that are permissionless and trustless. So ideally, I would like those applications to become popular and be used on a daily basis. And I think that if those applications succeed and become big enough, then no government will be plausibly able to shut it down, or not shut it down, but like curb the access to it the same way that happened with Tornado Cash.
Yeah, I think like the good thing about like decentralized protocols and blockchains in general is that you don't have to ask permission for anything. If the technology is there, if the cryptography is strong enough, you can build your private or your privacy-focused app and just deploy it on chain. And you know, even if it's illegal, you don't care. Everything's decentralized, and that's a good thing about it.
So guys, I think we've almost run a couple of minutes over. Oh wow, you want to have questions? I'm so sorry. We're almost done with time. We're almost 5:30. We will get kicked out. So thank you all very much. Thank you, and thank you.
Hello, everybody. I know it's the second day and towards the end of the day. We're going to talk about a light topic, nothing technical. I am an engineer, but we're going to talk about something that I think influence all of us as users of crypto, which is custody. And what we're going to talk about today is the idea of hybrid custody, something that is really about how you use crypto. Who do you trust to hold your and control your assets? So since we're in a conference with an Ethereum logo on it, I will ask the question, how do you like your custody? Like, how do you like your eggs in the morning? And I'm pretty sure that everybody here is going to say, I like my custody self. I want to control my keys. And that's expected. Like, I think, with people who are familiar and understanding of the foundation of decentralization and in the Ethereum ecosystem, it's self or else. Why? Because or else FTX happens. You store your things and hoping other people will keep your things safe, and poof, it's gone forever. And we all know, not your keys, not your coins. That's something that I think we burn into the back of our heads so that we can survive in the morning and fight again and try to build a decentralized future. But the truth to be told is, how much do you trust yourself? What happens if you lose your keys? You lose your coins? I don't know, I'm not going to do a survey because it may be too embarrassing and a little bit too trigger warning. How many of you guys have lost the key and you lost the thing in it? How much do you trust that every private key you've ever generated in a seed phrase is not compromised, not screenshotted, nobody saw it, and is secure forever? And that's pretty scary. So the truth to be told is, there's an opportunity to lose your keys and lose your coins in the self version or the else version. This is a general problem. Either one of them, you have to trust someone that may not, at the end of the day, be trustworthy. I'm not saying I don't trust myself, but I'm saying that some days I wake up in the morning and it's like, you know what, I really want someone who's doing this professionally. So who's that someone else? And at the end of the day, the word hybrid custody is about understanding, is there a way for us to put together, through the magic of smart contract wallet, account abstraction, all the things you've heard about during this particular period in the last 2 days, about balancing the value and allowing yourself to say, I want to have control over, but in case something goes wrong, I want someone else to help me, let's say, recover my face. I want someone to automate this action for me so I don't have to click every single time. But if they start doing something crazy, and maybe not what I intend, I want to take it back, I want to cancel, I want to retake control. How do you balance those two factors? And that's what we want to explore today with hybrid custody. So it's an and/or. For the programmers and the Boolean logic nerds here, we probably need both trusting yourself and someone else, or depends on the situation. So let's take a look at what we're talking about this. We look at hybrid custody not as like either or, but it's really a continuum. So on one hand, you look at this like, you put the Ethereum logo in the middle. Hybrid custody is like, what happens if you aim right in the middle? That would be hybrid. But that doesn't say much, right? What's the truth is how do you balance between trusting yourself, which is do it yourself, you have full control, to trusting someone else, which is do it for me. It's not just about trusting, it's actually quite useful. I like the fact that my bank pays my bill every month, recurring. That's a nice thing to have, someone do it for you. On crypto, you're responsible. Someone's gonna bug you on Telegram if you don't do something because you forgot to do something. So the truth is that there's always been this idea that in the work that you do and in the tools you use within Web3 and crypto, there's certain tools you use in exchange that you actually like the fact that someone's doing for you, and sometimes you want to make sure that you're in control. If you're using MetaMask, you're probably trusting yourself, and a lot of things originate from that. But you guys also use Coinbase, Binance, hopefully not FTX, and nobody here has any FTX exposure, because why would you? Or why wouldn't you? Who knows? This center part, which is all the different ways that we can balance this hosted service and owning your own key, is really what I want to explore today. So it's not just about one point within this map, it's multiple points. In the next section, I'm going to talk a little bit, some examples of what type of scenario, use cases, or patterns of hybrid custody that we can achieve. So one thing is clear. What we need architecturally is this idea of a smart account. And a smart account is what we call, as more technologists in the formation, is technology account abstraction. Is it possible for us to create an account that's not tied to a key, but is something, a smart contract that can contain assets and stuff like that? And we use that as the starting point and say, who can control and do stuff with that smart account, with that safe? So let's start there. So revisiting the diagram we had before, at the root of this is this idea of a smart account, and for the purpose of this discussion, we're going to say no to Safe or Safe, right? Safe Global, they have a new rebrand, pretty great. Cardstack, an organization building UI on top of the ecosystem. We are Safe Guardian, proud to be part of the community. There are many other approaches for smart contract wallet. They're all applicable. Account abstraction is an Ethereum thing, not a specific project. But for simplicity, let's just say you have a safe. And on that safe, you can imagine that the control of that safe is both something that you can do with your keys, something that you directly have in control. And then your provider, someone you choose to represent you and help you in your journey, also have some key that have some partial control of it. But if you look at the smart account itself, it is on a network. It's on mainnet, otherwise. It has an address. It contains token and NFT or whatever you can put in them. It could be credential, driver license, verifiable claims, anything we think that can be in Web3, it's in that safe. No different than what can be in your MetaMask. The difference here is that Safe, as a smart contract wallet, has this extension mechanism called Safe modules. They're kind of like plugins for your Safe that allows you to add additional logic in controlling this smart account and say, in this condition, this can happen. When that condition, this happened. Only if this happened, that happens. A lot of logic that control this information. And that allows us to then say, what is the balance of powers between your own key and someone else's key that may control this account? I know it's a little abstract, so I'm going to go through about 5 examples of hybrid custody examples to show you the spectrum. Let's start with something pretty obvious, which is, let's go straight down the middle. What if you have a provider, like a financial, like a Coinbase or something like that, that controls your key, and they can do whatever you can do? Either one of you can do the same action. This is kind of like, you know, a one of 2 multi-sig, of which Coinbase has an account to sign your account, and you have. But the crazy thing about this is that right now, if you use Coinbase, you don't have the keys to sign your transaction, right? So this is actually a really new concept, even though it's just a one of 2 multi-sig. This is actually, from a financial services point of view, a segregated account, which means that your financial service provider is giving you an account that only your funds is in, and you have a key to transfer anytime, and so can they. Now you can imagine all the nice things that can happen, right? You can do your automatic transfer on the exchange, but you can also say, no, I revoke your rights. So both parties can withdraw anytime, no question asked. That's your key. Good. Hybrid number 1. They, however, can do all the same stuff. And they're like, oh, I'm just on my phone, I don't have my key. You can send a message, or you can, 2-factor authenticate, and they can do that as it was an exchange. And they can deduct to pay fees, things that you are too busy to do. But what they cannot do is that they cannot remove you as an owner. That's what the Safe module allows. You can revoke their rights, but they can't revoke yours. And that's not just a multi-sig, right? Because the Safe module we've added here provide a bit of a symmetry that gives you your key a little bit more preference, even for day-to-day basis, they can do the same thing. So that's a segregated account. Don't you think the people who thought they lost their money in Silicon Valley Bank thought that they had a segregated account and realized they don't? This is already an improvement over the financial service system that we have today. But let's look at another example, which is maybe I don't trust my service provider, my financial service provider that much. The second thing is what I talked about earlier, bill pay, recurring payment. I want to be able to sign that I want to pay this person every month at this amount using this token on this network. But I don't want to have to remember to sign it every time in this month. So what you do is that you pre-sign them, and you can say, hey, provider, every month at this time, please go and just send this transaction to the network. Don't change it, and they can change it. Whatever you sign is the only thing you can do. It's like mailing an envelope with a check already written, and just have someone say, okay, at this part of the month, I'll put it in the mail. That's all they can do, can't modify it. Now, if you want to cancel it, you can just like give me all back and you can cancel that and they can't do it. So recurring payment would be something that leans a little bit more on the self side, but still providing that utility you expect to be able to get from a provider without ever risking them deducting everything from your bank account. You can only authorize what you already set ahead of time. We built something like this, so we'll talk about that in a second. We'll come back to this. But let's keep going an example. The next example is a bit more like a robo-investment. So let's say you want to balance your exposure in crypto between stablecoin, ETH, and 4 other things. And you want to do some swap to make that happen. You can do it all yourself, every day. Do some calculation, make a spreadsheet, and make a bunch of transactions and do it. Or you can say, hey, provider, you have some data. Why didn't you figure out on the analysis of the market based on some database and some queries and some bots, stuff like that, and then determine what to do. And I delegate you. I set it up one time and authorize you to balance my portfolio with this goal. And people do that with their retirement account, right? If I get older, please trade to other assets. You can authorize that to do. And that authorization can be revoked. And that's really cool that they can't remove you, but you can remove them. So this leans towards trusting someone else to do other stuff, and that's on the other side, the hybrid thing. Now let's talk about 2 quick examples of things that happen to the best of us, which is what if you lose your seed phrase, where this key is just light up in fire and you either compromise it and accidentally deleted it or expose it, and now it's like, oh crap, I now don't have my key anymore. What do you do? And the nice thing about account abstraction is that you can create a new key, new seed phrase, and then you can use a mechanism that you set up hopefully ahead of time where you verify your identity to one or more service provider, could be your exchange, could even be a tech company like a Facebook login, and then they can say, well, the only thing I can do is to verify this person is who they claim to be. And if enough of these service provider, the people you use every day, the phones on your app, then they can reset your password just by saying, I validate. And you may need 2 of 3, you may need 7 of 16. I don't know. Depends on how you set it up. And then the smart contract say, I got enough information from these set of trusted recovery provider, could be your friends as well, could be a guardian type of situation, and then I'm gonna let you replace the primary owner with your own new key. Try and doing that with an EOA, right? So this is the nice thing about having this smart account abstraction is that you can now do this. Now change fields, all good, you're ready to go. But you will probably not want to do that again in the future, right? So you may want to say, hey, I'm going to use a hardware wallet, and then I'm going to use the hardware wallet as a primary form of recovery, maybe reduce the threshold, increase the threshold on these other providers. But this idea of being able to constantly in this triangle to subdivide the control over the account and subdivide the rules, or even trusting a DAO to help you recover something as one of the triangle, this thing can get like more fractal, it can get lower and lower. It's how we can build up a composable wallet infrastructure around account abstraction. And that's the thing that I think is missing in this certain idea is that we are thinking about the technology, how to make it, how to change the client, and not really think about the patterns. As you can see, just by 5 very simple examples of things that we have faced before, we're able to now see, hey, maybe this hybrid custody thing is really the way to move crypto forward. So in summary, hybrid custody is like a multi-sig signer, except it's limited through state module by logical rules to balance the power so you can actually delegate and maintain your rights along the way. I hope that makes sense. So we went ahead and say, you know what? That use case 2 was such a good idea, but maybe we can learn and validate this architecture by actually building an application on top of these tools, safe modules. And that's what we did. So we built a scheduled payment tool, which we think is a great use case. We have vendors and consultants and employees around the world. We want to pay them every month, and right now it's quite manual using MetaMask, sometimes exchanges. But what if we build a tool that can do that? And the way it works is now you can now visually see how this manifests itself in a dApp. This can be other dApps, it can be integrated with other platforms, but this is our version of it. So you connect your wallet, that gives you your key, the bottom left part of it. Now you create a payment safe. And this payment safe is essentially saying that there's a safe specifically built for you to pay people. So it's not maybe your treasury for your DAO, but maybe like a checking account that you create. And this save is only used to fund these transactions. You're the owner, so at no time that you deposit 2,000 USDC or 20,000, it's not under your control, you're the owner. And then when the scheduled times happen, the source code, which is open source, everything we do at Carstack is open source, will then submit your payment and complete the transaction. And by the way, we do have to make sure that you have enough gas. We deduct that ahead of time. It's like prepaid envelope, lick it and put it on and then mail it later on. We do some gas estimation and make sure that we have a little bit more gas than you probably need at the time of your transaction to make sure we have enough to actually do it then. This is much harder than it looks. We have to learn the hard way about these kind of rules when you're doing scheduled payment. But the idea here is that when that's all done, you schedule a payment, you figure out when, where is it going, who is it going. You want to pay max, min, high gas. We do a bunch of estimation. We deduct the money. We mine the transaction. We add it to a future payment. Set it and forget it. As long as this safe has enough money to support this transaction, if you do more transaction, you have to fund it more. And we'll tell you if you're missing something and ask you to deposit more. And when you're done, it just shows up in a past payment with a actual transaction on EtherScan on any network that support it. So that's hybrid custody. If I tell a person who has not used Web3 that this is amazing, there's like, this is what I expected last year, the year before. But this is really what's possible once we have account abstraction in production and start designing protocol around the human experience of custody as a human concept versus gobbly-glug stuff that we talk about. The jargons are great, ZK is great, but this is how people are going to react to and learn how to use this tool so that they don't get their funds taken by a bank when they go to a business or exchange when they steal the money. So I'm proud to announce today that this week we finally launched what you just saw, HTTPS safe-tools.carstack.com. It's a tool that demonstrates the ability for us to do this thing. It's in beta. There are some, node issues and performance issues we're working on, but it works and it's end-to-end and you can use it. And, we're announcing here. And this allows us to essentially show that this type of user interface is possible, the infrastructure is there, and everything, including the modules and the smart contract is in github.com/Carstack is open source for all to see. We're trying to move it forward, doing something at a time. But I'll leave you with a final thought before I depart. If you go back to that diagram, right, trust yourself, trust someone else, and then all your stuff in accounts. If Web3 were to win it all, that this actually becomes the way everybody interacts with the world, the stuff in your account is your certificate, is your completion, is your relationship, is your contracts, right? Not just money, but maybe asset claims and insurance policy. All of this stuff that we're building on top of Web3 are just the primitive that goes into accounts, or EOA, or in this case, smart contract accounts. We are only right now worrying about how do we get 1 billion people using it by improving the wallet, browser-based wallet, mobile wallet, hardware wallet, or things that people are inventing. I think that's really important. But as I hopefully have shown you, we still need to think about who else do we trust if the user were to lose their coin? What other ways to make that so that it's usable? But I'm a little bit concerned about this trust someone else being only big tech vendors, financial institutions, and governments. What have we done if all we did is say, hey, I own the key, but I'm still dependent on these existing power structure that exist? So the question is, what else can I trust to determine whether I am who I am, whether this is going to be a low enough risk thing to do this transaction? The truth is, with all the stuff that's talking about ChatGPT, you can certainly imagine a relatively well-trained AI algorithm to look at the patterns of detection of what's happening and say, I don't think you're doing this swap at 4 a.m. in the morning, right? That this seems wrong to me. Let me just flag it and maybe wait 3 hours until you wake up, until you approve the second time. So I'm not trusting someone else to say I can't do this. I can override it. It's like 2 signatures. I don't care. But it could be good to have something that's running in the background, protecting you, kind of like your second factor, just making sure that you are in Dubai and not someone else using your keys or your phones in Dubai. This is the thing that you cannot do on chain. But tech vendors like Google can alert me, it's like, this is not an expected login location. Could we do that, but without Google being in the equation? So essentially, could we build a network using these algorithms that doesn't require us to trust a single company, but have a consensus network of AI and ML algorithm working like smart contract, checking each other, right, or like a validator to make that happen. The reason I say that is that we build context safe tools on the way to the journey of building an AI ML consensus network that uses data science tool like Python to do these kind of data aggregation and analysis. And then we realize that even if we can do that to automate, to verify, to delay, to block, to suggest and allow, how do we control and help people actually executing that without making ourselves a centralized provider where you have to trust us with funds? And that's when we realize, hey, we need to work on this safe tool to use account abstraction to give the human the authority and the control so that the machine, hopefully decentralized and run as a network, can balance out the human agency that we need to do to survive any AI, that I can stop this Skynet right now. I revoke your permission. But still, on most days, like, I'm too lazy to deal with that. Please go do that for me today. That combination is beautiful and probably the only way forward. And it's the combination, as crazy and ridiculous as it sounds, between the control we have done in Web3 and blockchain on keys and the AI ML that allows us to automate and handle the complexity of the world without personally grokking and doing everything and approving every transaction on your MetaMask. AI and blockchain combined is bullshit, but not if you do it the right way. And hopefully, as we've talked about today, and we'll announce what this will look like on the future in the protocol we're building, the hybrid custody is probably a way forward. And I think we all deserve the credit of having made the self-custody part important. Now let's make sure that this is sensible and usable for everybody in the world beyond what's in the room today. So thank you very much. My name is Chris C., founding director of the Costech Project, and follow me at Chris C., and hopefully we can continue this conversation. Thanks.
All right, everybody, how's it going? Just want to say hello. My name is Mark Anstead. I do business development over at Fuji Finance. And today we're going to be talking about the evolution of an application. But before I get started, I know it's been a very busy last couple days, so to everybody in the audience, thank you for joining and listening in, and hopefully you guys learned something new and have been able to learn something new over the last couple days. So let's jump into it. So going over a little bit of the history of just applications in general, we're going to be talking about how applications have sort of evolved over the last couple of years or last few years, and where I sort of see them evolving moving forward. So moving back a few years, the first large application on Ethereum really launched back in 2016. This is known as the DAO. Unfortunately, this dApp that was launched didn't really have the best outcome, ended up getting hacked, and this ended up creating the creation of Ethereum Classic. And then shortly thereafter, the first mainstream application that was launched was in 2017, very well known as CryptoKitties. This basically clogged the entire Ethereum network, became super popular, and everybody was trading it, and it was a lot of fun. And then after the boom of all these ICOs that were happening in 2017, many dApp developers, they needed to determine which network that they were going to be going and deploying different types of applications to. And if we go back a few years, there were a few different networks that people could look to deploy on. So if people were around a few years ago, some of these networks might seem a little bit familiar or maybe dated. So like Ethereum, EOS, Tron, Steemit, Clayton, even Neo. Some of these things don't really exist for the most part anymore, but obviously around that time, Ethereum was the biggest and the baddest of them all. So why did so many applications go and deploy to Ethereum? You could go and permissionlessly deploy and build virtually anything. It had the largest developer community. A lot of the tooling was beautiful. It was the most mature, secure, and decentralized chain out there. So all of these developers were like, this is where we have to go and deploy. If you're deploying anywhere else, you're probably not doing it properly. But, as many people know, life on Ethereum isn't necessarily perfect. I mean, I've been a builder on Ethereum. I love it, but it's got its flaws. During that time, there were a lot of gas spikes. We still have gas spikes today, though we're looking to improve on that. But back in like 2017 and 2018, there was a huge gas spike around CryptoKitties. And then coming into 2020, with DeFi summer, it was absolutely insane. Just going and making like a regular ERC20 transfer, sending like USDC, could cost you as much as like $50 to $100. It was brutal, and that led to some of these memes saying these gas prices are too damn high. It was not fun for your ETH that you had to spend. And this essentially evolved into what's known as the multi-chain thesis. Basically, every single dApp developer realized, okay, with all of these fees just getting absolutely insane, we would be crazy just to stick to Ethereum, because if you do, most likely some of your activity is going to decrease because it's becoming too expensive for some of your users. And developers, they needed to look for alternatives. And since Solidity and the EVM became the norm, a lot of these other chains started to get activity, and people started to deploy to them. And some of these retail users were like, oh, this is a little bit nicer. It's a little bit cheaper. It's a little bit faster. And some of these side chains started to get a lot of growth. So like BSC, now known as BNB Chain, Polygon POS, XDAI, Phantom, and even Avalanche's C Chain. They all started to really flourish and grow in terms of activity. But with a multi-chain thesis, there are going to be different types of pros and cons. Obviously, you have better throughput, you have lower fees, you're still able to have EVM compatibility, and you have a new community that you're able to go and market to. Some of the cons are fragmented liquidity, and obviously you're not really going to be secured by Ethereum. You have different types of security assumptions. And this actually ended up giving the rise to different types of L2s. I mean, I'm not going to lie, I'm very biased. I am a huge L2 bull. I have been for quite some time. And many of these networks during this period of time, they were heads down in development. They weren't actually production ready. But some of these solutions are now starting to evolve and come into production. So some of these are like optimistic rollups and ZK rollups. I'm a big fan of both of those solutions and some of the teams that are building them. And the TVL for them are starting to explode. And so why are some of the teams going and now building on layer 2? Well, it's cheaper than Ethereum, similar to some of these EVM side chains. It's secured by mainnet, so any transaction that's occurring, you're still able to have security of Ethereum. It's faster, can still support the EVM, and a lot of the tooling can be very similar. So for some of these like optimistic rollups as an example, you can have what's known as EVM equivalence. That means that you don't have to have any type of changes to your code to go and deploy it onto these types of networks. And even some ZK rollups are working towards that as well. But with this multi-chain thesis and L2, it is still causing problems. Liquidity has now been fragmented. So if you're a user building around DeFi, it can get a little bit hectic, especially if you're playing around with significantly larger amounts of capital. This liquidity is now separated on all of these different silos and these different, I would just call them verticals. So on all these different networks like Ethereum, BNB Chain, Tron, Arbitrum, Optimism, Polygon, Avalanche, Phantom, all of these different solutions, they all have their own isolated ecosystems. They can't communicate with one another. It's a big problem, and as we're looking to really scale out these ecosystems as a whole, or these types of applications, it becomes a problem. And as new L2s are able to be deployed, it is a permissionless process to deploy an L2. This fragmentation, it's only going to continue. And this has now led to a new breed of type of application that we've seen over the last, I would say, like 6 to 12, maybe even 18 months. And these are different types of cross-chain applications. And the goal of them is to really abstract away the use of individual types of networks to optimize the user experience. And if you're like a DeFi application, to unify the liquidity that has now been fragmented. So we're going to just take a quick peek at a few examples of a few teams that are focusing on these types of solutions, which is Sushi Foundation, LeFi, Fuji Finance. I will say I'm a little bit biased there. I'm on the team at Fuji, as well as Radiant Capital. So starting off with Sushi, for those of you who aren't really familiar with Sushi, they did sort of a vampire attack to Uniswap back in 2020 during the mid of DeFi summer. And they were really only deployed to Ethereum. They went through the same life cycle. They were a single chain, then they went multi-chain. They were like, okay, if you're any type of EVM compatible network, Sushi is deploying there. That was like their mindset. And over the last 6 to 12 months, they've taken a very different approach because they have all of this liquidity on all of these different networks, but it's all fragmented. So they've been working with actually the Layer 0 team to build what's now known as Sushi XSwap, where you can not only bridge assets across different networks, you can also swap through the different types of Sushi swap pools. So you're able to access the liquidity on all of these different networks. And one of the cool things about it is you can view the route with how like the trade and the transaction is actually occurring. And so it really helps to make that user experience a lot better. It's helping to unify the liquidity when you're going to make these trades. Another one is LeFi. They've sort of taken a similar approach to SushiSwap around cross-chain swapping, although they have gone, I would say, one step further in terms of what they are offering. Because not only are they a cross-chain swap aggregator, similar to like Paraswap, or 1inch or DexAG, but they're also a bridge aggregator. So they go and aggregate all of the different types of liquidity layers and messaging layers to essentially go and offer not only the best bridge, but also the best swap for you as a user. So different types of applications are starting to integrate with them and build on top of their SDK. So one of the things that's actually really cool that they're working on right now, which for me as a user, outside of just swapping ERC20 tokens, which I do fairly frequently, is the ability to go and purchase any NFT from any chain. So for me, like I primarily use Ethereum and many of like the L2s on Ethereum, but I might not be using some of these side chains that some of these NFT projects are going and deploying on. Well, with LeFi, with one of the things that they're working on, you will then be able to go and just have your assets on the origin chain and go and say, I want to purchase this NFT on XYZ chain. And your funds from the origin chain can be swapped into a bridge asset or just bridge the origin asset and swap into another asset to purchase that NFT. And that can all be done very seamlessly from the end user's experience. So making that process a lot simpler. Another example is Fuji Finance. We are building, I should say we, I'm on the team, we are building a cross-chain money market aggregator where you can deposit, borrow, and repay a position from any chain. So one of the things that we have seen over the last couple of years since the lending markets have really started to evolve and essentially gone multi-chain is we're starting to see new smart contracts getting deployed on all these chains. We're seeing new networks being deployed. And all these money markets, they're fragmented. And so the Fuji team is essentially looking to unify all of this liquidity and allow you to access it through one interface. So you can go and essentially optimize either your yield or your borrow rates from all of these different types of money markets. Another example, which has actually gotten a lot of hype, I would say, recently, especially on crypto Twitter, is Radiant Capital. They are building what's known as a omni-chain money market. So you can deposit and borrow an asset from any chain. They're actually building on top of layer 0, and currently the money market that they are working on, this V2, it's not live just yet. Their V1 is live on Arbitrum, and then their V2 is going to be live built on top of layer 0, so you can do all these cool functionalities. And it's really helping to make that user experience significantly better, and it just really helps out the end user and people that are building on top of these solutions. So the big question here, are cross-chain apps perfect? We're probably moving into this new paradigm where developers are going to start architecting and building their products to be natively cross-chain. Are they perfect? Short answer is no. But all of these teams are working towards being as trustless as possible, similar to any other type of normal application. Because none can be guaranteed to be perfect, not even Uniswap or Compound or Aave, the biggest behemoths of them all. None of them are technically perfect. We can strive towards perfection, but it's not guaranteed to happen. And these types of solutions, they're simply an evolution of application architecture to make the end user's experience significantly better and to help onboard more users and make this whole process that much easier for users and developers to build around. So that's all I have for you all today. Again, thank you all for listening. My name is Mark Ansted. I'm on the Fuji team, and yeah, I hope you all have had a wonderful time over the last couple days. And yeah, if you guys have any questions, feel free, raise your hand. You can speak out loud, feel free. If not, thank you all for your time, and cheers. Do you have a question? Oh, okay, cool. Thank you guys. Enjoy.